all of you at NTIC 2022. It is exciting to see that all of us are gathered here to understand and discuss the impact of innovation. I, Yashwardhan Singh, along with my colleague, Mr. Amit Verma, will be the host of this event today. So the first session lined up for today is Sustainable Solutions for Water Utilities under Robotics and AI. And the session will be presented by Mr. Asim, CEO at Fluid Robotics Private Limited. Now, I would like to hand it over to Mr. Asim to initiate the discussions.
So presentation is going up from there. Okay. Left, right. Hello. Hi. Okay. Perfect. Awesome. Thanks a lot for this opportunity to Nasscom. I'd just like to get a sense of who all are in the room. Anyone from IT? Government? No? Anyone from investment banking? No? So I guess, or academia? No. Okay, cool. So my name is Asim Bhalirao. I'm one of the founders of Fluid Robotics. As you can see, we're a wastewater analytics company, and wastewater spans many sectors. And I'd like to start with like a summary of what we've done so far, and I'll get into why we're doing it and how we're doing it. So just the last year was recovery from COVID. We've monitored about 1.5 million feet of pipelines across the world using our analytics solution. We've monitored over 1.5 billion liters of urban pollution in India alone, out of which only about, say, 60% of it is now being treated after we've monitored it. And we're currently monitoring about 12.5 million people for infectious diseases through wastewater. That includes COVID. And we've, through all of this, been able to prevent about 12,000 hours of manual scavenging. So I come from a tech background. My partner Nidhi also from tech. My background's mostly robotics, AI. Worked in Silicon Valley for about 10 years before starting the company. My partner Nidhi comes from a software product management background, and we've got a great set of partners that includes the government of India and some international accelerators, including Nasscom and Imagine H2O. So I'll get into the problem. Now, in India, about 50 billion liters of untreated wastewater is being discharged into the environment every single day. So that's, wastewater going to lakes, rivers, coastlines, or just, somewhere in the environment. And this is a problem that's not limited to cities in developing countries like India. Even countries like the US see about 9 billion liters of untreated wastewater being discharged. So it's a big environmental problem that cities across the world are dealing with. And the root cause really is old, unmanaged underground infrastructure. Now, looking at the other end of the spectrum, now looking at public health, as we all know, the global population's quite vulnerable to infectious diseases, as we've seen in the last few years. And things like climate change, population growth, antimicrobial resistance are only increasing that vulnerability. So the public health is also in a state of crisis at the moment. And we've seen this, nobody was able to predict COVID, till it actually happened and spread across. So I'll walk you through, a couple of areas where we've been able to provide solutions. So how do we prevent untreated wastewater from getting into the environment? This is a snapshot of a lake. Usually lakes, rivers, coastlines, these are the ones that feel the most impact of untreated wastewater. So we provide pollution monitoring services to governments. That includes mapping topographies around these water bodies, identifying the source of pollution, and looking at the entire wastewater system that's present around a specific water body. And I say, existing infrastructure has a very important role to play in preventing pollution. A lot of cities are building new infrastructure. There's a lot of government efforts because population is going to double in the next 10 to 15. Urban population is going to double. Therefore, new infrastructure is important, but older infrastructure is equally important. So what we do, when the government hires us to solve pollution for a specific water body, the very first step is, create a model of the entire water body. So this is a river in Mumbai called Mithi River. This is a 3D model that's been generated from drone data that we've captured. And this helps us identify all the points where untreated wastewater is flowing into the water body. These are called outfalls. So we map out all the outfalls. So Mithi River is about 17 kilometers, has about 200 outfalls across the river. It starts at Vihar Lake, flows through or under the airport and into Mahim Bay. So it's a relatively small river, but it basically carries a lot of untreated wastewater. Now, once we've identified all these locations, the next step is to do two things. Quantify how much is flowing in from every point, and second, is it domestic waste that's coming in or is it industrial waste? So these are the two areas that we look at initially. So we basically divide the river into several areas. We look at, we basically deploy robots into these drains to monitor how much volume is flowing through each drain. And then we basically do some real-time quality analysis, we do some in-lab testing, and we figure out, okay, how does this wastewater need to be treated? So we basically do this analysis. You can see, divided into area 1, 54 outfalls, and about 8 million liters a day is being discharged collectively through those 54 outfalls. So we basically quantify the pollution. We take a data-driven approach. Similarly, we look at all the other areas. On the right, you can see that's Mumbai Airport. The river flows adjacent to it, and whenever it rains heavily, we actually see a lot of flooding in that area, and I'll tell you why that tends to happen. Now, these outfalls are basically drains that connect some source of wastewater to a water body. There is a parallel network of pipelines that also connects the source, but to a treatment plant. So you have these two networks that are present in every city. Unfortunately, 80% today is flowing through these open drains or nalas. Only about 10 to 15, maybe at the most 20% flowing through these networked pipes to a treatment plant. So once we've analyzed all the wastewater going through these drains, the next step is we deploy the robots into these pipe networks, map out those networks because the cities usually don't have these maps, and then identify connectivity of that network and capacity of that network. So connectivity to a treatment plant, capacity to see are these pipelines underutilized anywhere. And most of the times we see that these pipelines are underutilized and the treatment plant that they're connected to are also underutilized. So the next step is basically to map out this system and run our analytics to find out what the condition is, what that extra capacity is. Can that hold any additional wastewater? And then, once we've looked at these two sets of data, we've looked at how much quantum is present, and we've seen how much capacity is available in an adjacent network, we basically identify or plan the interception and diversion of this network into the sewer network. So we look at optimizing this existing infrastructure, take wastewater away from a water body, push it into the sewer network wherever there is additional capacity, and then send it off to treatment. And this network optimization approach is so cost effective because every treatment plant that you build requires about 2 to 3 crores for 1 million liters a day that you want to treat. And we've monitored over 1.3 billion liters. 700 million liters is now being diverted through this approach at a fraction of the cost. So there's a huge benefit to optimizing existing networks where the current focus is always new infrastructure. We help deploy our technology to do this. And we've done this in about a dozen Indian cities. Um, and once we all of this, one of the byproduct is we know exactly where these pipes need to be repaired as well. You don't need to dig up entire roads. You can actually pinpoint where the issues are. You fix only where needed. So there's a cost benefit into repair and rehabilitation as well. Now with COVID, all business sort of stopped, right? We're working on government projects, and unfortunately, a lot of these government projects are not backed by policy. So it's not mandated to do this kind of work, unfortunately, at the moment in India. So during COVID, we realized that our knowledge of mapping wastewater networks, understanding how wastewater flows through a city, can actually be a good way to test for the spread of COVID at a macro level. There are individuals, everyone goes out to a clinic, gets tested. We know how many positive cases there are of COVID through RT-PCR tests. We figured out that we could do this through wastewater. There's a lot of work happening in Europe already on this, and in fact, polio is being tracked in some countries through wastewater. So we figured out, okay, if we build some capacity, understand what it takes at a microbiology level to do this, we could actually track the presence of COVID, and this could potentially be a way to predict and potentially prevent outbreaks. So we took our robots, deployed them into drains again, but this time to collect samples, filter samples, and then to run this testing in a lab for COVID. So this is a map of Pune. We're currently monitoring 3 cities where 100% of the population's wastewater gets sampled every week. And we've been deploying this across these cities, monitoring about 12.5 million people. And one of the things that we've seen, so when anyone gets infected, it takes about a week, sometimes more or less, to develop symptoms. It takes time. You go to a place, you get tested. Sometimes you don't even get tested. But your body starts releasing fragments of the virus on almost day 1, day 2. And we are tracking that wastewater. And when we track that wastewater for COVID, we are able to predict when an outbreak is going to happen almost by a week, 8 days. So we're able to actually do that with Omicron. We were able to track the presence of Omicron in Pune wastewater about 8 days before the first clinical test was reported in India. So there's a huge benefit to doing, and we've now expanded this to include other infectious diseases. So COVID's a major outbreak, but every city has micro outbreaks. So one of the cities that we're working in, they have rotavirus outbreaks impacting children. There is drinking water mixing with sewage water coming through taps, fecal contamination. We're able to track that. We're able to track hepatitis. So a lot of these different diseases, outbreaks, could be tracked through wastewater. And the process is quite simple. The teams go out into the field. We've identified strategic locations. Robots get deployed. They collect samples, filter them out, store them at specific temperatures. And then all of these samples are taken to labs. We work with different labs in different cities. So we'll send our microbiologists to city 1, wherever sampling is happening. They'll test these samples. They'll test for the presence of, for example, for COVID, they'll test the presence of the RNA. They'll look at the viral load. And they'll also do genomic sequencing to see what strain it is. So we can even track that now. Before, there used to be like single strains. You had just one delta. Then we went to like 40, 50 strains of delta. Now Omicron's another beast. So, the presence, the viral load right now in wastewater in Pune is quite high. It's higher than what it was during the peak of Omicron. So it's interesting to see that the vaccinations are working quite well. There are no hospitalizations. So there is, you can sort of back up a lot of the work that the government is doing based on the data that we've been able to collect. And we're able to work with some really prominent partners like AIMS, NCL, Government of India as well, to run these programs. Now what's happening is, we've sort of identified how these 3 areas link together. You have wastewater infrastructure. If that's not maintained, that impacts the health of lakes and rivers. And eventually that water feeds back into agriculture, into drinking water for cities or towns or villages that are downstream of larger cities, like for example, Pune. And how all of these 3 link. Public health is linked to to waterways, and eventually to wastewater infrastructure. So we've realized that you can't work in one area without impacting the other. And I'll just spend now just a couple of slides on the technology itself. So we have a combination of mobile robots and static multi-sensor devices. These are basically hardware devices that are deployed in the field to collect data. Now in places like India, Bangladesh, some Southeast Asian countries, there is no data. So unfortunately, we have to build the data collection capabilities. So we do that in-house. And then all of that data feeds into our analytics platform, which is called Fluid AI, which takes in all this data, whether it's video data, whether it's sonar data, LiDAR data, quality data, flow data. All of these parameters go into our analytics, and we're able to derive insights into how particular areas functioning when it comes to wastewater and even public health now. So the good thing is, internationally, there's a lot of hardware already present. There's already a lot of data collection happening, mandated by government. So, US, Singapore, European countries. There we're able to leverage that data and just deploy our analytics. Very easy way for us to go to market in a lot of international places. So we now work with customers in about 6 countries just in the last 1 year. And they've been using our analytics. In India, it's a slightly slow process. Data collection is equally important. And yeah, and last couple of slides. So there's a snapshot of the robot. Another robot here that's collecting data. We collect data underwater, above water, and that's about it. Am I allowed to take questions, or are we good? Good. Okay. All right. Thank you so much for this opportunity. Yeah, I hope you had a, a good experience.
So, thank you, Asim. You can stay on the stage. Thank you, Asim, for such an informative session and discussing about the sustainable future, solutions of the sustainable future with us. So we have a small gratitude from us, a token of appreciation. So we have planted a tree in your name. So now we will be starting the next session shortly. Our next session is SaaSification of the product, and that will be presented by Mr. Shirish, EVP Advanced Engineering at Icertis. Now, I would like to Mr. Shirish, to initiate the discussions.
Hi, good morning all. My name is Shirish. I'm the Executive Vice President of Advanced Engineering at Icertis. It's a great pleasure to be in front of all of you leaders to talk about the SaaSification of the product in general with a little bit of focus on Icertis' journey of the SaaSification. So with that, here is the agenda that I'm attempting to cover in approximately 20 minutes with leaving 5 minutes for question and answers at the end. We'll talk focused on the benefits of SaaSification for your business if you are going to undertake this journey. what are the benefits are going to be for your customers, and then coming back into internally, because this is supposed to be a technical session, we'll talk about what are the core benefits for your engineering organization when you are undertaking the SaaSification journey. And then we will move shortly on to our journey of SaaSification, which we started in 2009. I joined Icertis in 2009 as well. So we'll talk a little bit about that, and then I want to leave you with key takeaways from this particular session, which is something that you can carry back to your organization if you are going to undertake this journey. So this is real deal that we have actually experienced right from 2009 to 2022 right now. Little bit of my background, I joined in Icertis in 2009. Currently in CTO organization as taking care of advanced engineering, focusing on vNext. When we started journey in 2009, I was taking care of the platform engineering, where we were focused on building the product first, then taking it in front of the customer in the next logical step, building the professional services organization, then carved out a support organization, then handed over those organization to respective leaders, and then I came back to platform engineering again. And right now I have moved on to the CTO organization, focused on the advanced engineering. What is going to be vNext for Icertis? That's what I'm focusing on right now. Little bit about Icertis. As we said, we started in 2009. 2,200 plus employees right now. It's been a great journey. I'm proud and fortunate to be the first engineering hire at Icertis. Now it is 2,200 plus organization. Great journey, I can tell you that. 2 development centers, one in Pune, another in Seattle. 3 support centers, again Pune, West Coast, and we have one in Europe, Sofia. 10 million plus contracts managed, and we are in the CLM market leaders. If any of you are tracking the Gartner or the Forrester quarters, we are right at the corner, at the top. So let's establish some brief terminology before we get started. SaaS, everybody knows software as a service. When earlier product used to be delivered, those were delivered as SaaS, which is SAP, which is software as a product. So there was a journey from software as a product to software as a service. That is what we are talking about here. SaaS applications typically are based on infrastructure as a service, IaaS, and platform as a service. Platform as a service typically sits on top of infrastructure as a service. Infrastructure as a service is delivered by cloud service providers, AWS, Google Cloud, Azure, etc., etc. Now, let's move on to what are the key benefits for your business if you are going to undertake the SaaS journey, and why you should undertake the SaaS journey in the first. So you could potentially develop the new revenue streams if you start thinking about SaaS in your current way of working. I'll give a very concrete and specific example around this. When Amazon was started as an e-commerce system, right? Back in 2002, Bezos had hosted an executive sort of offsite at his home. And they were going to discuss a key problem. What is the key problem faced by Amazon at that point of time? And then the executive said that whenever we are going to initiate a new project, that project initiation is taking 2 to 3 months of lead time. And then they went and did the deep dive into that and found out what was the real cause. And then they found out that getting the softwares and hardwares and specifications, etc., was taking longer. So they came up with the idea, why don't we create a central organization which is going to provide this as a service to our internal consumers, internal project managers, etc., etc. And then in 2006, Bezos sponsored a project which was a successful in-house. Then they came up with the idea of, now we have sort of figured out how to do this, satisfy this internally, why don't we start offering this outside also? And that's how AWS was really started, which was started as an infrastructure as a service. They slowly built on to making that as a platform as a service by offering other services like Elastic Cloud, for example, EC2. Then they immediately came up with S3, simple storage service. Such small services they started adding, and that's how this entire multi-billion-dollar business was formed. Okay, so you could actually do the same thing, really. Another simple example, my brother is a chartered accountant. He uses Tally software. And using Tally software, Tally allows you to do a little bit of customizations here and there, right? So now he has figured out that whatever stuff that I have done on top of Tally, I could offer it to other chartered accountants who could benefit from the same. That's what I'm talking about here, which is generating potential new revenue streams. The second one is faster time to market. This is what actually Amazon executives also saw. Once you have a central service which is going to help us give the infrastructure as a service, platform as a service, I could concentrate on my core business problem and start delivering my solutions faster to the market. That's what the second point is. The third one is faster sales cycle than SAP. SAP, again, software as a product. However way the software was getting delivered earlier. Now, don't get me wrong, every sale is difficult. I know that. But now we are comparing this with selling a software as a product. Now, selling software as a service is inherently a little bit simpler because faster time to market plays advantage there, where now you can offer a customized demo to your prospects very quickly on your SaaS product. And then the second one is customer is coming to the table with a mindset that I'm not getting married to this product for the lifetime. I am just going to buy your services, I'm going to pay as you go. So my commitment to your service is very limited, so I can take some risk. And that is what plays a role in the sales cycle. The next one is the faster growth. You would inherently see that land and expand happens very easily in a SaaS model than in a SAP model, because now customer has already tried some of your services. He's open to try something else from you. So expanding into a prospect which is already landed is always easier. The other major advantage here is that you are always building your revenue on top of what you have acquired in the last quarter, because it is a recurring revenue in the SaaS model. So now if you have done a sale of $10 million in quarter one, you are beginning quarter two with a $10 million ARR already, and you are going to build on top of it. And because of all of this, market looks at your SaaS business extremely sort of in a greater valuation perspective very favorably. Getting 10 to 20 times ARR valuation is almost a given right now for a SaaS company. Getting to 30 times also is, some companies have achieved that. The way market is looking at your valuation is what they call as a rule of 40. Has anybody heard of rule of 40? So rule of 40 is defined as your growth percentage and add to your profitability percentage. That number has to be 40 or more. If that number is 40 or more, market is going to look at your business favorably. They are going to say that your business is healthy, it's going to survive well, which means you could grow at 60% and have 20% negative profitability. Market is okay with that because your still number is 40. And these numbers start playing when your journey is initially, when you are starting your journey, obviously you are spending more dollars to get your customers, so your profitability is going to take a hit, but your growth percentage is going to be higher. And that's how market is going to look into this. Now let's move quickly on to what are the benefits for your customer. You obviously see the easy accessibility because the software is now getting delivered to your end users at your customer typically through the browser, from the cloud, etc. Now customers don't have to worry about what is the hardware that I'm going to need, what is the software that I'm going to need. All you need is typically a browser and an internet connection. And most of the SaaS softwares are delivered through that, barring few where you would require a thin client to be deployed. For example, Microsoft Office, you could use it online completely, or you could have the small thin clients onto your boxes also. The second one is low upfront cost. We talked briefly about that, right? Now you are not marrying to this particular provider for the lifetime, paying the huge upfront fees. Instead, you are signing up for pay as you go. Sometimes businesses have come up with the model of based on the business outcome also, which means you pay only for the returns that you have got from this particular system. The second is better scalability and maintainability. Very concrete example here, Best Buy is one of our customers. Best Buy is a big retail electronics shop in United States. Their demands are fluctuating. At the time of the Thanksgiving, for example, their demands are really huge. Around the Christmas, their demands are huge. So you inherently get the advantage of cloud elasticity if your provider is a SaaS provider based on the cloud. And that's what the better scalability means. Maintainability is now customers don't have to worry about maintaining this particular software if it was deployed in-house, whether my software is going to have the denial of service attacks, how well is security defined, all of that is taken care by your software provider. The next one is easy upgrades. If any of you have gone through upgrades of big in-house systems like SAP, for example, which lasted for like multi-year project, SAP upgrades. And by the time you are done with one upgrade, you are almost ready to get onto another upgrade, and then you are constantly on the treadmill. But with the SaaS, if your provider has done his business really well, and we will talk briefly about that also in the later part, your upgrades are almost instantaneous. You don't even know the upgrade has happened in the backend, right? That's what the good SaaS provider is, who is actually delivering upgrades to you without you knowing about the upgrades. So gone are the days where their upgrades used to run as a multi-year project. And then the next one is better personalization. Most of the SaaS products which are delivered, one of the advantages is that they give the ability to customize, personalize. You can sort of develop your own extensions onto their SaaS offering. And we'll talk a little bit about that also. So with all of this, customers are also inclined to go on to the SaaS journey with you if you decide to go there. Now let's get back into engineering and see what are the benefits for our own engineering organization if you decide to undertake this particular journey. The first one is now, which we talked in the Amazon example, where their executives could focus on their key business problem rather than worrying about the software and hardware and basic services, etc. Because you have already zeroed in on a particular cloud provider, which is going to provide the infrastructure as a service, it is going to provide the platform as a service. Now you could completely focus on the business problem that you have without worrying about all the underlying details. That's the main basic advantage. Imagine most of your engineering organization is focused on solving the real business problem which is going to deliver value to your customers. The next one is, if you have done your engineering really well, and if you are able to deliver upgrades and software delivery very quickly, seamlessly, your DevOps is so robustly done, then you can deliver your software to your broader customer base extremely quickly. Once you deliver that quickly, you can learn from that broader customer base also very fast. And I'll tell you from our experience, no matter how much testing you do in-house, learning from the key customers, there is no way you can replicate that in-house. And that is why it is ultra critical to take your software in front of your customers as quickly as possible, learn from that, make changes, deliver the patch, but just be on that particular train, bandwagon all the time. And that is, you are going to keep yourself on toes, but you are going to delight your customer all the time. Remember, the SaaS model is customer has liberty to leave you at any point of time. Typically, the SaaS agreements are such that within a 1 month notice, customer can really close the deal. So protecting your churn is defined as number of customers leaving in a particular quarter, whatever duration that you choose. Protecting your churn is going to be ultra critical for you. And such initiatives are going to be helpful, very helpful. That is how you build a culture of continuous improvement. Now, remember, back in the days of SAP, which is software as a product, the mentality was, if something is broken, we need to fix it. But now the mentality is slowly changing, that if I see an opportunity to improve, I will go ahead and make improvement, because delivering the patch and the upgrade is very straightforward to me, very easy. I can literally upgrade my customers during the night of the product is delivered. Now with all of that, if you do all of this well, this is the most important benefit for any engineering organization. If you are able to deliver your product with only one active branch of your source code, this is the best thing that can happen to you. Imagine you are thousands of engineers, and we are not talking about services organization here, we are talking about product organization. With a product organization, 1,000 is a huge number. And if 1,000 people are working on a single branch, delivering the next version of your product, that's the best thing that can happen. And we'll talk about this also as to how we have achieved this. Now we have established what are the benefits for your business, for your customers, for your engineering organization. How did we go about doing all of this when we undertook this particular journey? So these are the two terminology which I wanted to first establish, whether everybody is fully aware of that, because I have seen people using these terminologies very interchangeably. Product and platform are two different things. Product is really where you are focused only on a particular solution for a particular business problem. That's what product is all about. Whereas in platform, what you are doing is you are focusing on building the common infrastructure where you are going to enable building multiple such products. So there is a very huge difference between that. And the important thing is for all of us to understand this really well so that we all start talking the same terminology internally as well as externally also. When you are talking with your customers, you need to position yourself whether you are a product company or a platform company, because these are two different things. If it is a platform company, every single person in your organization has to understand that I am working in a platform company, which means every decision that I'm going to take, and it could be a very small decision as writing a code, or it could be a decision as choosing a cloud provider. All such decisions are affected by this particular thing, and that is why I strongly recommend that define yourself really well. Whether you are a product company or a platform company, stick to that, explain the terminology well internally. Every single person starts using the same terminology, that we are a platform company. Right from the beginning, back in 2009, we decided that we are going to be a platform company. But please note that every platform company always has a great product also. You cannot survive just by writing a platform right from day one. You have to have a continuous revenue stream that is developed by a particular product. So you develop a product, you expand your wings, define that I'm going to now start building a platform, and building a platform means my product is going to sit on my particular platform, and then I'm enabling others also to come on my particular platform, build your own applications. Imagine the marketplace that has been developed by Salesforce. That's what our vision is also. That is where we are going to take Icertis. Now let's focus really quickly on Icertis SaaS journey. We started back in 2009. Azure was picking up. Azure started in 2010. We decided to stick on Azure. We were already a Microsoft shop. So sticking on to Microsoft, taking a bet on Azure was the next logical thing for us. We decided to do that, take that particular bet. Next is building the engineering organization with a SaaS platform mindset. That is why it was critical to make sure that every single person in your organization understands what a SaaS is going to be and what a platform company is going to be. And we are going to try and create a SaaS platform, which means every decision that I take in engineering has to deliver fruits towards these two goals that I have in mind, which is SaaS and a platform. These are the two goals that we had in mind. Once you build this, and of course, building in engineering, I'm sure most of you have done that. When you are the first engineering hire, getting the second engineering hire is not easy, because you want to make sure that you bring on the bright minds, but more importantly, they are culturally fit also, right? And that is where the challenge is. And once you are starting, you don't have a brand to go with. You can't attract people when you don't have a brand, which means the one-to-one communication that you are doing with all your prospective hires also becomes ultra critical. Of course, after you have hired the engineering, after you have sort of achieved some success, you have achieved a brand value, then attracting talent becomes easier. But that initial journey is extremely hard. The next logical step in the SaaS evolution, obviously, once you have had a product with a platform mindset that eventually I'm going to sort of grow into a platform, the next thing is take whatever you have built in front of your customers. Again, the key learning that we have sort of got from this is taking your engineers in front of your customers is ultra critical, key to your success. Because if engineer is sitting just in front of his laptop and coding without understanding how the software is being used by the end customer to solve the business problem, because this is not an R&D organization. We are not just writing algorithms and code here. We are here to solve a real business problem, deliver value to our customers. That is our core goal is. And delivering value to our customers in a SaaS model becomes critical because customers are focused on getting that value or they are ready to walk away. Very easy. So delivering value to our customers means building the professional services organization. And again, coming up with the best practices for implementation, etc., etc. That's all happened over there. And then the next stage came is delighting your customers. Customers need to be delighted every day in a SaaS world. The moment they see a hiccup, they start getting into a different mindset. Am I with the right provider or not? And that is why delighting customers, and that is why we use this particular terminology. We don't call this support, by the way. We are in the business of delighting our customers. That is, through our professional services, we provide value to our customers. Then we move on to providing the continuous value to our customers day in, day out, and delighting them. That is, understanding if there is any underlying pain area, finding the solution with the robust engineering, develop the patch, deliver that very quickly, and continue to delight our customers on and on. And then once we are there, then obviously, and that is the stage that we are right now, which is evolve to scale. Now, once you have developed a certain mass, you have certain ARR in front of you, you want to achieve the rule of 40 so that market continues to look at you favorably. Rule of 40 again is your growth percentage and the profitability percentage. In the initial stages, your profitability is typically negative. You are focusing on getting the growth. Now, once you have achieved a certain mass of ARR, sustaining that growth on a significant number, like 100 million ARR, sustaining 60–80% growth is very difficult because your base number is so high right now. And that is why it is important to introduce the efficiency into the system so that your profitability continues to grow up and you continue to meet that balance. That balance is extremely critical. That is where we are now. Because we are a platform company, we want to have our own marketplace also, which means we want to enable our partners to do business on our platform. We want to create a revenue stream for our partners as well. So partners can come onto our platform, they can take up any business problem, they can solve that particular business problem by delivering a solution onto our platform, deliver that solution, we get a revenue. Same thing, you all have seen how the Salesforce works, right? Microsoft Dynamics CRM works, etc. Apple has, like on iPhone also there is a marketplace. You develop the applications, Apple takes their applications through the certification. That is what we also do. Our applications built on our platform go through our certification mechanism, etc. We ensure that the applications which are built on our platform are robust enough, because ultimately the customer is going to see that application coming from Icertis platform. And that is where we are right now. So overall, this has been the journey. Again, nothing very different than what you would have in mind, but the learnings are there in every step. And those learnings, the feedback mechanism from delivering value to your customer to engineering and delighting your customer back to professional services, back to engineering, those mechanisms, feedback loops in every stage are extremely critical. And that is how you will continue to build on the legacy that you have built so far. Let's move on to quickly. This is, I don't know why this is not showing, but this is Icertis SaaS. We'll talk a little bit about the engineering delivery, how we deliver the software very quickly to our customers. So these are the pods that we have created. First, central is the staging pod, and depending on the complexity of the customer, there are simple, medium, complex, and enterprise pod. Because ultimately, when you are delivering your software quickly to your customer, your risk is also high. Because you haven't had enough opportunity to test. Because customers use your platform in variety of different ways. So what we have built is this, our continuous delivery pipeline, one-click upgrade. That is, at the bottom of the click, your underlying platform gets upgraded. It goes through the automated validation. and then one-click production deployment. And that's how once the GA build is done, it goes through this particular pipeline, and on the staging part, the software gets delivered. And this all happens on the click of a button, literally. So imagine your customer's staging environment platform is upgraded now, at a click of a button. Customer can do the testing, etc., whatever is needed. We get the feedback. We talked about the feedback loop, remember? We get the feedback back, and the first patch gets developed in 3 weeks. That particular first patch goes to the staging as well as it directly goes to the simple part. And that is how we have reduced a little bit of risk. We have learned from the staging part's customer UAT, and then we went and deployed that onto the simple. And this particular thing continues. That is how we develop the patches. And ultimately, our train continues, and that's how this is our release N, and this is release N+1. So at any point of time, one version is running for the customer, another is running in the active development. Now move on to the quick one. What are the key takeaways? Mind shift of entire business, not just technology. Entire organization has to think about this. Careful choice of service providers, because whatever the service you are providing to your customer, underlying cloud providers, support you if you are outsourced, etc., it's all about that. The second one is focus on value to customers as well as organization. We talked about that. The value has to be proven every day to the customer because it is a SaaS offering. Listen to your customer and listen to your employees. This is one thing that interestingly we found out that the junior most person who is working on your product would have the best knowledge also about it. And make sure that you listen to all of them. And with all of that, take the leap and enjoy the journey. I'm sure that it is going to be a fulfilling journey. You will learn so much about it. Thank you so much. Thank you for that opportunity. Please feel free to contact me if there are any follow-up questions. I don't know whether we have time for any questions. No? Oh, we have 5 minutes? Okay, that's great. Yeah, please.
No doubt SaaS is great, right? But there's a point of conflict I see. We are facing that as well. So when you say we rely on one version, right? One common version, but at the same time you are saying we will do personalization as well and customization. So how does that go together? So as a customer, I need product A with my own customization, especially on the reporting side.
Yeah.
And the other customer will have a different reporting request. So as a customer, what I'm facing is the SaaS companies or product owners, they tell me, sorry, this is not on our roadmap because I can't have multiple versions, and that's what you were saying, we have to retain one version.
Yeah.
So how you delight the customer?
No, that's a great question. That goes back into your mindset of developing the platform. When you are developing the platform, you are developing the points for technical extensions. What extensions are possible on your platform? And we expose those APIs to your customers, our customers really. It could be reporting, it could be integration, it could be anything. So certain set of APIs are exposed. And in our platform, we ensure that version over version, the compatibility of those APIs is not disturbed at all. Now, when customer is asking for a particular extension, all we have to do is expose another API if it makes sense from our business point of view. And once API is exposed, that API has to be guaranteed to work release over release. So that's how we are attempting to do that. But again, this particular journey is extremely difficult. Whoever has been into this particular journey would understand that people are left with like 10s or 15s of code branches. Soon they realize that because initially you want to take as many customers as possible, right? And when you are trying to delight your customers, you take shortcuts. And again, everybody does that. Nothing wrong in that. But important thing is, when you have liberty and when you have time, it is important to go back and make the correction of those shortcuts and make sure that your API model is developed so robust. Again, another example, Microsoft, delighting the customer. Microsoft is using our product in completely headless fashion, which means they don't see our UI at all. And entire our product is enabled through API. So they have their own UI standards. Every organization does that. Like for big organizations, they have developed their own UI standards. Their customers, their users are sort of focused, used to using a UI in a certain way. As a SaaS provider, you cannot create a different set of UI just for one customer. But what you can do is you can enable your product through the API and let customer do their own UI development. And that's what we have achieved.
So the similar thing on the roadmap thing, right? What you mentioned. So what problem we're facing is that it's good for all, but where you manage confidential and secret data, the SaaS solutions are not actually ready with those solutions and the roadmap for managing those. That's why you see a lot of data breaches. So it's good where your normal data is there, but where you're handling secure or confidential data. So I see that entire portfolio needs to think and evolve on the security journey.
No,
I think basic
that's a good
security is
point.
there, but if you see whenever handling confidential and secret data, you don't have, I'm not telling you as such, but overall. So what we understand when you onboard, they're a good solution. We have to work with those teams and ask them to develop those controls in place so that we can.
Yeah, you're right. That's a great point also. So the way we have attempted to solve this particular problem, I'll tell you. When we have developed the multi-tenant solution, right, the data compromise happens if underlying database, there is a shared database that happens. So what we have done is our every customer is going to have its own database. But the running mechanism, the actual machines where the software is running is all shared. So we have developed a hybrid model to take care of this, but that's a great point. And especially in the contract management, people are not comfortable, right? Because people are hosting their contracts, and these are real contracts. For example, for Google, their ad contracts are there on the platform. Nobody would like anybody to see these contracts. Are we good? Yeah. Thank you. Thank you so much. You have been a great audience. Thank you, Nasscom, for the opportunity.
Thank you, Shirish. Thank you for sharing us your informative session on SaaSification and the key benefits around it. So this is a small token of appreciation from us. So Automating legacy data warehouse migration to the cloud. This is a panel discussion, and the panelists are Mr. Rahul Kulkarni, Head of Data, Insights and Knowledge at BP, Mr. Neeraj Kumar, Co-founder and CTO at Datametica Solutions Private Limited, and Mr. Saad Sekhon, Chief Digital and Information Officer at UBS. The session will be moderated by Mr. Prasad Deore, Senior Director at Nasscom. Over to you, Prasad.
We'll have context setting first.
Sure. So,
Hi, good morning, everyone. I hope this is a fantastic morning with all the coffees and a very welcome to all of you. So it's a very interesting topic. I would like to just set the context for our discussion. It's very important to know what we are going to talk about. The topic that we are going to discuss is the legacy data warehouse migrations to the cloud. That part, this itself, like, you can see the trend wherein people are started moving from their on-premise systems, including applications and data warehouses, to the cloud, including data lakes, a lot of patterns, data marts, etc., right? Including ETL, reporting, all that. So in this today's discussion, the context is, why are we going to do that? How should we approach? What kind of challenges have we faced? And how to overcome of that? Right? What are those risks, etc.? And is there a benefit? What's the challenge, etc.? Right? So that's the context of it. And I have put few slides. I'll just spend 10 minutes around this particular topic, and then we will get into the discussion. So if you look at why we are talking this particular subject, right? Look at the market. The market says in 2021, the overall worth of this particular industry was 9.3 billion. But now, towards 2025 or 2026, is going to be close to 24 billion, right? And that's why it's so important for us to focus on this particular topic, make sure that we are utilizing the opportunity in the right way. So that's the context of the topic, why we are here to discuss this subject. What's the trend that we are seeing into the market? And it's very common, we all know it. The very first trend that you are seeing is shifting to the cloud. And there are a lot of strategy that you will hear: cloud first, cloud native, all the applications migrations to the cloud, and data consolidations, etc. A lot of patterns that you will see. And it all has a lot of challenges. We as Datametica, we have implemented and migrated more than 100 warehouses, data lakes. You're going to see all of those experiences in these discussions, and my colleagues are also having a lot of experiences into their migration journey. That's the benefit that you're going to get here in this discussion. Faster data to access and real-time analytics. This is another pattern. People say, my data warehouse or data lakes, rather data warehouse more, is T-1, T-2. Meaning is the time when my business user is going to get access to the data, it's like already late, right? Can I turn this batch mode processing and availability of the data to real time? That's the pattern that we are seeing. And that's one of the motivation towards getting to the cloud, because we will get flexibility of getting the data faster in real time and make that data available to the cloud because of the scalability that cloud will provide, or flexibility that infrastructure will bring when we go to the cloud. The third, consolidating the data silos. Today, if you look at your data warehouse or the BI ecosystem itself, it has a lot of components. Trust me, I have worked with almost all the large enterprises, at banks, healthcare, retailers, etc. They all have multiple data warehouses, not one data warehouse. In theory, you should have one data warehouse, right? And that has its own scalability challenges. But assume like you have multiple data warehouses, multiple data lakes, multiple data marts, and even then, you are going to migrate to the cloud, expecting all of these artifacts like, real-time analytics, etc., you need to consolidate your data first, right? You should have a data strategy first. What are you going to do with that? So that brings another challenge to all of us. Let's think first, when I'm going to take all of this mesh from one bucket to another bucket, which is the cloud, am I going to have the similar advantage, or am I going to take the advantage of the challenges that we are going to see, like all of those real-time analytics or data science capabilities, etc., right? What's the benefit of it, right? So this is where people started thinking about, can I collapse all the data silos and have one single point of truth, which can say, this is my regulated data set, and I can make use of it for the data which I can trust at least, right? So that's another pattern that we are seeing. Advanced analytics and machine learning area, this is very popular, we all know. One of the motivation for taking to the cloud is, when we are going to do data science, as of now, we have been playing with all the sample data sets, not the entire data set. And it's like a garbage in, garbage out. If your sample is not correct, your inferences are not going to be correct, right? So what we are going to do is, we need such an infrastructure which is scalable enough to take care of huge data volume, right? And unstructured data set processing, and that requires a lot of compute. Where am I going to get that onto on-premise? That's another trend wherein people are so motivated to go to the cloud, because of to get that scale and the flexibility in infrastructure, so that I can uplift my business by doing some good work into data science, that particular area. And then we have put another point, when we are saying modernizing the legacy ETLs onto the cloud. If in our experience that we have seen, if your transactional system, which is OLTP, if it is generating 1 gig of data set, it is being replicated more than 25 times, right? And there is no need of it. And why it is happening? It is happening intentionally. The way we have started our journey in data warehouse, we started building the data warehouse for a purpose-oriented system. I have this particular report that I want to create. It requires this 4 data set, let's bring that. Tomorrow another report will come, you end up bringing the same data set. And how it is complicating your ETLs? It's like, redundant data set, very complex logic written everywhere. It's like a mess, it's not organized. Now you're going to take this whole thing to the cloud, although you will see better benefit in terms of scale, but do you think there is an opportunity to consolidate that? Answer is yes. And that's another motivation when people started thinking about, can I unify or consolidate my ETL, make it much more simpler? This is my source data. I can bring it to the data warehouse or data lake onto the cloud, and I can simplify my ETL using some consolidation of language, consolidation of processing, all the operands that you are playing. Can you consolidate that, unify that? But this all requires upfront strategy, right? That is very, very important. But these are the primary motivations to go to the cloud that we are seeing into as a trend. Now, the another thing that companies should think about is, when you are going to move the data, right? What exactly what are your drivers, right? So obviously we are expecting high performance. We are going to see lower TCO, right? We are expecting that there has to be total cost of ownership has to go down, because it has been like all the license-oriented, appliance-oriented world as of now. Hadoop has changed it a lot in terms of open source technology. Can I take advantage? Can I lower down my TCO? Security, governance, reliability. That's another thing which we will talk in maybe more detail if we get time. But security, etc., is a concern even today. But people are expecting this has to be reliable and much more secure when we are playing with the scale and when I'm going to put a lot of data onto one ecosystem. Consolidating data silos, we spoke about it. Real-time customer analytics, or any analytics rather, right? Data monetizations, etc. It requires a lot of scalability, right? And that's what cloud provides. That's another benefit. No maintenance, because over the time we are seeing, and you may relate this, right? There was a world, maybe 20 years ago or maybe 15 years ago, when Chef, Puppet, these all were so popular. This market went down when EC2, GCP, virtual machines, etc. came into picture. Then Terraform came into picture, and then the Kubernetes-based deployment came into picture. What have we done? We have reduced the burden of infrastructure team, right? So, and now we started questioning, why even Kubernetes? right? Your computes are compute. I mean, do we need to containerize really, right? So we can, that's a very different subject, but that's the no maintenance part. Highly scalable, we all know about it because there is a dynamic scale that you can scale to. Advanced analytics, ML learning, and then accelerated time to value market. So, well, as of now, we saw how, I mean, what motivates me to go to the cloud? Is it a need? Yes, it is a need, because you need scalability, right? You want to get, so agnostic to the technology and the infrastructure, right? That's the motivation. And you have a lot of business drivers on other side. Let's see the challenges that we have faced, right? And challenges are in all the ways, starting from the design challenges. Your ETL, when we say, okay, I'm going to migrate my data warehouse, this topic itself is legacy data warehouse, which includes Teradata, Netezza, Exadata, and all that, including Hadoop, right? That became legacy technology very soon. So if you look at, when you say data warehouse, it's not only a database. It has ETL, it has shell script, it has a lot of other proprietary scripts, and then it has a reporting part of it, right? It's not alone one database that you're going to migrate. What would you do with the other stuff that you have, right? So there is a design challenge which you have to think about what is my scope when we are going to migrate to the cloud. It may not be single phase approach. It could be multi-phase approach wherein you are going to put a design for taking all of these to the cloud so that you can take advantage of the better scale, right? So it's very deep, and one of the challenges that we are always seeing in all these companies, they don't know the end-to-end lineage. There is no product as such which provides end-to-end lineage. Data stage provides lineage for their own transformation, which is happening inside data stage. Something is inside the database, but where is end-to-end lineage, right? That's a very incomplete story. And that's a big challenge. The data dependencies are the big challenge. If I ask you this particular report of Tableau, tell me the entire lineage all the way from the source, there is no way you can extract that data set. Even if you look at it, it could be very high level. You will lose the operators, like what kind of processing is being done on that kind of data sets. So those are the challenges, redundant data set, etc. Then the challenge comes under the development. Even though I have 6,000 number of ETL jobs, 20,000 of tables, 4,000 of stored procedures. I mean, how would I take it to the cloud? I need to translate all of these to the new technology, right? And that's a big challenge. Am I going to do it manually? Answer is no. You are going to take 3 years of time to manually recode it, and then by that time your warehouse has been changed completely, right? So that's another challenge which we have to think about. How can I kind of overcome that? All of these cloud technologies, databases have their own limitations. All of these. It is quite different than your traditional data warehouses like Teradata, etc. They are very, very mature system. In order to achieve the scale, that brings a lot of limitations, and we all know CAP theorem, etc. And there are workarounds to solve those kind of challenges. But these are the challenges that you will see in the development. Then the data validation. Even though if I have migrated all of my data sets, all of my ETL, how can I ensure that the data is correct, right? Otherwise, it's going to impact the business. And that much of data, if you are going to validate and move the data from Teradata to, let's say, onto the cloud, there's no way to validate that much of data after every ETL processing. That's the big challenge, right? And then the last one is optimization challenge. Well, we all know that, and the previous slide said that cost was one of my drivers to get to the cloud. And until we optimize and efficiently write all the codes into the newer technology as per the new technology constructs, right? I'm not going to achieve that optimization. I'm not going to achieve that, advantages of the new technologies that could, the stuff that have motivated me, right? And if yes, then while your translation is happening, you actually observe the access patterns, ingestion patterns, processing patterns to take care of all of those constructs, the complexities, all of that, and keep in considerations of your cloud native stuff, and then you design your warehouse. And that's exactly a big challenge. It's not lift and shift. There are a lot more that you could do. So that was the challenge. Now, how to do all of that? 2 minutes more. This is my last slide. All right, thanks. So, well, we all saw the challenges and the motivations, etc., right? So how should we prepare for it? My biggest takeaway and the experience that I have learned is, Don't do big bang approach. Don't jump over it, right? I have a data warehouse, let's take it to the cloud. That's not the approach. You prepare yourself with a full-fledged, a complete strategy going to the cloud, because you are not only going to take something like one technology to the cloud, but related consumers, related data curators, related data processors, you are going to take all of them, and you are going to convert a lot of notions to the cloud. So what we recommend is this particular approach to follow through. Prepare and discover yourself. Like, put a strategy. What motivates you? What's your driver? What's your levers to get there, right? And then you do assessments and put a plan. Your plan should not be like, I have 20,000 tables to the data warehouse, 6,000 to the jobs. Let's all migrate it, in 3 months' time. It is not going to work. So you have to plan it as per the data dependencies, etc. But you need to know those data dependencies, right? And that's what this access and plan comes into picture. Prioritize all of them, group them all together, and then take it sprint by sprint, which will include the repeat of all of these 3 steps that you can see: migrate data, translate your workloads, and then validate. Exactly the design challenges that I was talking about in the previous slides will actually come here. That's the process that we have followed for other customers. Instead of big bang approach, do it sprint by sprint. When I say sprint, it is not like agile method sprint. When I say sprint, meaning is identify, break your entire complex warehouse into small clusters. Take cluster by cluster and migrate those users and their workloads, etc. Don't do big bang. That's all. I wanted to set the context, and I hope this is very clear. Why we are going to migrate to the cloud, what are the challenges, the benefits, and how we should approach to. Over to you, Prasad. Thank you.
Raj. Well, really happy to be amongst the data experts. And especially, I hope this will be a spicy discussion, and we'll get some conflicting views. Not all the rosy pictures, and that's why we have Saj from UBS and Rahul from BP here. Neeraj, since you took a lot more time than expected, I'm going to focus more on Saj and Rahul. No issues. So, data warehouse, it could be a dumping yard or gold mine. It's always evolving. Any new application that is onboarded, any new project that comes up, it's a business initiative, technology upgrade, you'll always see a data warehouse team part of that program. I would like to understand from you, Saj, and then Rahul, what is the state of data warehouse in your respective organizations?
Right, thanks, Prasad. I think a friend Neeraj might have answered most of those questions anyway. You might need a new set.
I have a new set.
I think, look, I work for a bank, and one of the first things which we do when we engage with everyone is, as you know, the boring part of KYC. So before I start answering some of the questions, I'd like to just have a quick check around the room. How many of the people here are engineers? Can you raise your hand? Like proper engineers. You checked something into GitHub last week, not like kabhi kuch kiya tha, right? How many of you are data scientists? Okay, good. Okay, so the state of data warehouses. So see, we're an old bank, 106-year-old, and businesses grow organically and inorganically. And data, if you think, is an asset which grows along with the way the business changes. So obviously, our landscape in terms of data warehouses is sporadic. It's aligned to in terms of different lines of business. But that is what it was, and it is kind of in a transformation state. But that is definitely not where we want to get to, right? And I think that is true with any large organization, right? But what is important is that we have a very cohesive data strategy, which is backed up with a very solid cloud strategy. And I think as we go through some of the other discussions, which it'll be quite key to understand that before you start on the journey of any transformation of shifting data from here and there, or go through some of the interesting patterns which Neeraj talked about, what is important is to put the consumer at the center of the journey. In terms of how do you see the way that data is consumed today, how is it different from the way it was consumed yesterday, right? Yesterday's consumer was very different. Yesterday's consumer of data believed in data points. Today's consumer wants insights, right? Yesterday's consumer wanted MI, right? Today's consumer wants more business intelligence and the ability to interact with data, right? Rather than getting an end state of the data. And that is now
shifting the way how we see the data strategies evolving around the organizations. And in some of those strategies, the data warehouse actually has a very small part to play. There are much more larger things at play, which we'll discuss through the session.
Okay, so thanks for that, Saj. I think I echo most of the things he says. But if I look at it from the lens of our organization, so where we find ourselves today is, right, it's like, let's not call something as a warehouse anymore, right? So I probably call it as a data ecosystem, because the kind of usage, right, has changed, right? You still have analytic users, right? They still need dashboards and things like that. But then you've got the set of users who are trying to reach the next curve, right? This would be your data scientists and your data analysts and stuff like that. So what you need to provide is a platform, right, which clearly segregates who's looking at what. What we have been trying to do so far is either shoehorn all the data into a warehouse. That doesn't work because it takes too long to deliver. Or we go to a data lake kind of concept where, it's like just raw data. So what ends up happening is if you have certain calculations that you use, right, people keep on doing it time and again, right? So it's about finding that balance, and hence I would call it a data ecosystem. And the way we are trying to change stuff in BP is we are not migrating source systems in a warehouse to the cloud, right? I think those days are gone, wherein, you kind of said, okay, I've got 10 systems, 100 systems in my warehouse, and I'm moving 10 across. It doesn't work that way. So what we are doing in BP is we are now moving to feature-based migrations, right? So what we are saying is, you tell us what's the most pressing problem you have today, which your current ecosystem doesn't handle. And that's the bit that moves to the cloud first, okay? And that's how we are building our warehouses as well. So no longer 100 tables from 10 systems, and then we'll see what to do with it, but we only pick up pieces of work wherein you tell us what is there at the end, and then we'll work on that. Now that could be bringing data across multiple sources or whatever, but what you start seeing is, right, the value come through. So I think that's going to be one seismic shift where we need to go, and that's what we are trying to do as a part of our transformation in BP.
Thank you so much, Rahul. Neeraj, coming back to you, you talked about various trends, but from industry perspective, you're serving so many clients, large enterprises. Where do you see adoption for data warehouse legacy, data warehouse migrating to the cloud? Where do you see the fastest adoption? What are the key industry shifts or trends from that perspective?
A great question. From industry perspective, initially, and that has been a trend itself. So when data warehouse has its own legacy, it has led the industry since for good 3 decades. Hadoop came in all of a sudden and changed everything, like at least the perception, right? And the adoption industry, the very first adoption industry I have always seen is retailers. It's the easiest one, and they stumble upon it because of some problem, and then they go to that particular new technology. It happened with Hadoop, it happened with cloud also. Cloud has its own challenge because of retailer business may not work together, but they have other options, not only AWS, they have GCP, they have, so all those kind of challenges are there. But I've seen retailers coming first, followed by, nowadays, so one of the biggest challenge for cloud adoption was compliance and info security, right? So it took some time for, InfoSec guys to build the confidence onto the cloud. If I'm going to put my data to the cloud, is it safe, right? And it's an evolving process. It is still evolving in my knowledge. I'm seeing all of other industries. But followed by retailers, they build the confidence, and people started seeing the maturity in that curve. Now I'm seeing more and more banks. Now I'm seeing more and more healthcares, and all of these cloud providers making their, ecosystems compliant to this governance. So now the trend that I'm seeing is very high trend into banking, healthcare, and telecom. It was earlier, the rate was very high in terms of retailers, but now I'm seeing all of these sensitive data providers or curators coming to the cloud. That's the trend that we are seeing now.
how is business reacting to this, Sergeant Rahul? You talk about cloud and migrating data warehouses. What are their concerns? He raised a point about compliance. There might be confidentiality compliance because there are multiple data warehouses or data lakes or data marts, as you call it. So how is business reacting to this? What is their perspective?
See, the key thing is that when you start on a journey like this, you have to have a partnership with the business. Technology is just an enabler, right? And that partnership basically has to have an element of trust in terms of what we're trying to do. And secondly, I think I agree that there's an element of where InfoSec had to kind of scale up and kind of believe it, but we operate in a global environment, right? So, and then that global environment, it's just not our internal controls which sometimes can inhibit our acceleration, right? For example, when you have a cloud strategy and when you have a data strategy, obviously you have an info security strategy as well along with that. And if you look at it from another lens, I don't think there's any bank or any other institution in the world which has more security certifications than the cloud providers. They have multiple times the number of security certification. But the question that comes is that we operate in a global environment where some of the geopolitical challenges come into play, right? And what we're doing is when you're operating across multiple geographies, you're operating across multiple regulatory regimes. And some regulators are ahead of the journey, some are catching up, and that is where then you have to navigate carefully in terms of how you operate in terms of your hosting services, how you operate in terms of your data storage services, and that is the roadmap then you have to define, and those are the challenges you have to overcome. I think as organizations adopt some of those cloud and data strategies, they can very quickly formulate an internal InfoSec strategy, which is consistent across the globe. And then take that strategy across to the different regulatory regime, different countries, jurisdictions, and try and align their data migration roadmap across. So it is not a journey which is limited to, like I said, data warehouse. Data warehouse is one output of that. It is your whole strategy of cloud adoption and data on the cloud, I think, which drives some of these challenges.
Thank you.
So, Prasad, if you look at it with time, right, again, the business have been asking for the same thing, right? Quicker insights turned around fast, right? So there's no point, so for example, if you're in banking and you have this brilliant idea, right? You want it turned around in weeks, not months, right? So, I mean, ever since I've been in data warehousing, that's been this thing. So it's, whether it's the cloud or it's Hadoop or whatever it is, right? It's more of a technical implementation, so to speak, right? They don't care how you do it as long as you do it faster, right? So I think in terms of business adoption, right, it's about not selling that this is the new shiniest thing, right? You don't want to fail with the new shiny thing, right? There used to be this old joke with Microsoft, right? They said that, okay, I had a Windows machine which had like 8 gigs of RAM and whatever, and then now I've moved to a 32 gig RAM machine. The joke used to be, it'll hang up faster, right? You don't want to be in that place when it comes to your data strategy. So it's all about delivering that data, delivering it quickly, right? So from that perspective, it's not just the technology, because it's the cloud today, it's going to be something tomorrow, right? It has to be a sound methodology that sits behind it, which uses the cloud as a stepping stone to deliver these insights faster, right? So if you want the business on site, right, you have to prove it to them that when things change, you are able to adapt quickly, right? So I think that's going to be one of the major bits that we do when it comes to the cloud. Now, the bit that helps us is you've got an ecosystem. You don't have to trial and put new softwares in because it comes as a package sort of thing, right? So I think it's about the agility, the speed, and the methodology, right, that will kind of work closely when you deliver something to the business, and then it'll kind of deliver value. So it's got to be about a value-driven approach, and how do you then use the cloud to kind of accelerate that is something is up to you.
Thank you, Rahul. From implementation perspective, what kind of accelerators are available, and what is the approach actually? You do a lot of sort of implementations, Neeraj. What is your approach? What are tools and accelerators you recommend? and there are so many actually in the market. But how do you approach? How do you pick what is the best feed? So I would like to start with you, Neeraj.
Sure. So, in terms of acceleration, I'll answer it in a very structured way. There are three step approach that we will have to follow, right? One is you have to put enough time in order to put a strategy and design in place. Strategy, design, and plan. So you need a set of accelerators for that. And I'll come on this particular, in this quadrant a little bit. So, and then the second step is, now the migration will start, right? So then the migration part itself. There are a lot of accelerators inside this. Then the third one is certification of it. Now I have migrated, how would I certify that what I have migrated is actually accurate, right? Or else, it will be a failure. So if you start with the first bucket, what is important is to put a strategy first in terms of your drivers, accelerators. So there is no accelerators for it because it is business dependent, right? So you have internal discussions and have a rock solid strategy. For design and plan, you need to study a lot of patterns, access patterns, ingestion patterns, consumption patterns of your data set. Keep in your mind that your migration is not going to be lift and shift always, right? So there will be changes. So you need to prepare yourself for those changes and identify upfront, right? Try to eliminate all of those technical dates or functional dates even if it is there. How to do that? There are a lot of accelerators in the market which does the log churning, the database logs, it reads, ETL mapping it reads, and stitches the lineage all the way end to end, and give you a way to classify and categorize your data set to visualize from different lenses, complexity-wise, pipeline-wise, usage-wise, all of that, data redundancy perspective, etc. Some of them, we also have our own accelerator called Eagle. You may read about it later. But there are a lot of such products in the market which does, and even if you're not using those products, if you are using your own product which does the lineage, for example, Colibra, for example, other stuff that, Waterline, and there are a lot of products which does the lineage. But the important part is not the lineage. The important part is take that data set and classify, categorize in a way that you are able to read those access patterns, ingestion patterns, and consumption patterns and put them into a cluster. You can't really migrate 30,000 workloads in 3 months. So that is one part of accelerators. Second part of accelerator is code conversion, ETL conversion, reporting conversion, etc. Right? You need a translator. So there are a lot of translator, in the market. Cloud providers started doing their own translators. Like Google has Compiler Works. We also have Raven, which takes care of your ETL translation, like data stage translation completely into ELT fashion, etc. Not only the SQL. Snowflake has its own translator. So utilize all of those translators. Make sure it is generating the right data set. But remember, none of these translators are 100% accurate because there will be certain failures. People have written their code not keeping, like Teradata code, not keeping cloud in mind, right? So you will have to change those code base, as per the cloud compatibility. So that's the conscious thing that you will have to think about those before you pick up those accelerators. The third part is certification. How do I reconcile my data set or validate my data set, so that I can certify and be confident that my migration has been completed? And there are a lot of tools, even in open source technologies, to validate the 2 different data sets. There are a lot of data quality products like IDQ. There are a lot of open source event technologies that validates the data. We also have something called Pelican because Eagle, Raven, Pelican creates a bird family. So, but if you just ignore the product, what you need is, I need such a product which validates the data between 2 different databases or 2 different data sets without moving the data, right? That's where the intelligence has to be. Because you can't really move the data, terabytes of data again and again after every ETL runs. That's not practically possible, right? And this is where we have put our brain, or we have to put our brain, how can I pick such a right product as per my complexity and the data volume to accelerate those. But these are the 3 buckets which you should plan, and these are those accelerators that you can think about.
Thank you so much, Neeraj.
So, Prasad, can I just add one thing? So we spoke about the technology aspects, right? So the other bit that we have to keep in mind is the methodology you use, right? So what we are trying to do in BP is we are using the data vault methodology. So that's kind of an amalgamation of, agile, technical ways of working and decoupling your architecture. So the technology stuff will accelerate things, but your team's got to know the methodology you're using. Skimble or what, that's a different thing, but knowing what exactly you're doing is like most important, because the technical components then bolt on and accelerate those things. So that's something which people need to kind of come up to speed as well.
Thank you. You have any other views on this?
Yeah, I think I agree with what Rahul said, that the tooling will always be there, and there'll be better and better tooling as we progress. I think when you're trying to unwire years of kind of data wrangling, I think the first thing is to kind of have a data as a product view, right? So you need to be able to identify what is it you want to move, who wants to be first in terms of consumption, I think, like Rahul said earlier, and tie it to that prioritization, right? And I think we are a big supporter of the way we adopt agile, and I think that is one of the ways to kind of create value much earlier than kind of looking at a whole large program at the end of 2 years or 3 years, which is going to create some value for the customers. So this incremental value adoption as you move data and your processes to the cloud, and a feedback loop from the end users back, that really helps you create the next gen kind of a data strategy on the cloud.
Thank you so much, Saj. So I have a question now. We'll go to rapid fire, but before that, Saj, you said that data warehouse is not the driving strategy for cloud. Obviously, there are apps and other things. Now I'm asking from ROI or cost-benefit perspective. Forget other apps, but if you are handling data warehouse, you are managing the team, or you're responsible for data warehouse programs, do you see cloud is helping you cost-wise?
I think cost is one driver, but not the only driver. And I think if you...
We will come to other drivers, but I just want to cost here.
Yeah. If you're not very careful, that driver can go horribly wrong very fast, right? So the adoption of cloud is not just about changing your hosting services and your infrastructure, but it's about changing the way you work as well, right? So when you go into that kind of a design phase and strategy where you're moving, let's say a data warehouse, let's say hypothetically we're doing a lift and shift, you have to be really careful in terms of exactly what is the data and what are the services you want to enable in there. You need to have an analytics, a cost insight, a logging strategy upfront, and not post-implementation. So you need to be really careful in terms of what is it you want to compute, what is it you want to store, is there a way you want to segregate the storage and the compute use cases based, because both have very different costing models on every cloud provider. And then you should also be able to look at how you use your non-prod estate, right? We're all here quite used to the old ways that once you get you get some infrastructure for dev and test, that's there for life, nobody shuts it down. Whereas, welcome to the cloud. You leave it for a couple of days and you'll see a big bill on your Amex if you're using a personal account. So those are the things which add up over time, right? When you shut down, what are your services which you provide 24/7? What are the services which need to be provided certain times of the day in a particular location? And is that the way you want to manage your cloud hosting and your enabling? And based on the usage demand of your customer base, is it seasonal? Is it going to peak quarterly? Is it going to peak for certain processes at year end? You need to be able to have your infrastructure strategy on the cloud, which is scalable to that, so that you get the best bang for your buck. Like I said, cost is one driver, but it can go horribly wrong if you don't look at all of these upfront.
Thank you so much. Any other views, any conflicting views on this?
Not conflicting as such, but I think further to what Saj said, right? It's about the mindset shift that's needed, right? So I mean, I've seen people move things lock, stock, but the whole concept of scaling out and scaling back in never features into any design discussions. So designing is going to be like a very crucial bit, right? Which generally takes the last, or takes a very backseat unless something goes wrong, or if the costs go way too high. So it's more about, I think just don't look at it from a cost perspective that, it's going to be less, it could be more as well. So you have to, again, I keep harping about the fact that look at cost and value sort of thing. So at times it's about the value that drives things, right? And then, I mean, if you just did something on-prem and it took like 6 months to develop, right? And you did something on the cloud in 3 months because you had like variety of things happening, that's still again something. So it's not just the TCO bit, but you have to kind of look at that in terms of the value that you bring, right? And then you kind of bring it together and then look at it. So just cost in itself is not the right thing to measure.
Thank you so much. Well, let's go to rapid fire. Benefits of data warehouse on cloud beyond cost savings. Cost saving, there are conflicting views, but what are the other benefits, one or two benefits quickly?
I think lead time definitely, it can go down. Like Rahul said, there are certain things you can adapt fairly quickly, right? So that is definitely one for me, lead time.
See, from our perspective, we are in BP, and one of the key things we are doing is about being net zero at some point in time, right? So for us, the various tools available on the cloud, right, the various configs available on the cloud. So for us, not only are we looking at the cost savings, but we are also looking at running things efficiently and, in a way that, the way we want to tier data. So we basically breaking data into multiple tiers. And then what we are doing is, depending on those tiers, we are then defining SLAs for queries and stuff like that, right? So while we do this, another calculation we are also keeping in mind is the leaner we run and the efficient we run, right? End of the day, that's less CPU cycles, less IO, which is less cost, one thing. But if you kind of equate that to the carbon footprint as well, right? That's important for us as well. So we are looking at things holistically in terms of that. Not only do we want to kind of, have things efficient, but we're also looking at our footprint in terms of, the amount of carbon we use, the amount of power we use, and those kind of things. So things like shutting down, all those kind of things, and, using it efficiently is very important for us.
So you're moving to green data warehouse.
That's what we're trying to.
Okay, Neeraj?
Yeah, so I agree with Saj and Rahul. Lead time, faster access to the data, and, there are many things that we can do, not only in terms of cost, but we also have to see the value, how it is getting. Along with that, I would suggest, I would say in my experience is, all the data warehouse migrations are giving a very different kind of opportunity and avenue to relook the entire platform in terms of governance, right? What exactly is happening when you are going to migrate, you are actually going to relook and find an opportunity to remove those technical debts and functional debts that I was talking about, right? That's the biggest advantage that I'm seeing if you do it mindfully, then you are going to save a lot of cost, improved performance, and faster access to the data scientist and the business users. And obviously cloud provides such a tool, just plug in interfaces so that data scientists can play with it, and instead of focusing on data curation or ETL jobs, they can focus on real insights, right? And if you do it really good, then you're going to take advantage of it. I'll be very crude about it, and I'll be very direct saying that if it is better, and if you don't do it mindfully, then it is going to be it is going to be costly, right? So instead of just taking what you have onto the legacy platform, take it to the cloud, may not give you much advantages. Along with all of these, you put a strategy up front, and then you're going to take advantage of it.
Thank you so much. From skills perspective, what kind of skills you think are very important? You being GCCs, you have in-house teams. What are the skills, top 2-3 skills you think are important to run the show?
See, I think the natural answer everybody's expecting is, data skills and Python and things like that. And that was my first question, how many of our engineers here? A lot of our engineers were born into the digital age, right? So access to these tools and these concepts is not difficult. I would say the biggest skill that we need is the analytical mind and the culture. The technology will move on. The new skills can be acquired from a technology point of view. But I think as long as you have that cultural mindset in terms of treating data as an asset, right? And always looking at value creation out of data and not just, like I said earlier, data points. I think that is the most important skill set, because that's a skill set not just for our engineers, that's a skill set which is key for our product owners, that's a key skill set for product managers, right? And I think that is the skill set which we need top to bottom in the organization. Because our engineers across will all have the engineering skills, but I think it's that mindset of treating data as an asset which is most important.
So from my perspective, I think the key skill is, being able to understand the whole paradigm behind the data that you're working on. So it's like, we can learn SQL, we can learn the cloud and things like that, but as you start working, right, invest time and effort in understanding the domain you work on. Because if you are able to figure out how does the data elements come together and you're able to complete that analysis, right, that is where, the whole bit of converting data to an information asset takes place, right? And as long as your teams just look at data as a table and just work on it in a silo, right, what happens is you have a complete disjointed set of things. So from our perspective, what we're looking at is people who have that mindset, who spend that extra time and energy in trying to understand that whole data set, that whole domain, because once you're able to do that in one domain, you can then move across multiple domains, right? Technical skills can be picked up anytime, but that whole ability to start with a data set, being able to link it with other data sets, understand the domain, right? That's the key skills you need in warehouses. Because from a GCC standpoint, if you ask me, that's where the whole IP of the organization is. And if you can't develop that skill, then it becomes a big challenge, because the whole design, the modeling, and everything is like the basis for the whole warehouse thing. So if you don't get that right, then you have a product which is like really not that good, because you haven't understood anything and everything sits behind it. So my suggestion and the way I operate with my teams is that spend more time, understand the domain. Because once you get that, then the whole value gets unlocked.
Thank you so much. I'm coming to the last sensitive question. How do the customers, your business owners, would rate you or rate the data warehouse initiatives on a scale of 1 to 10, 10 being the most satisfied and 1 being the least satisfied? We just need the numbers. I'm putting you in trouble, but I still want that from you. There's no one answer, but still, how would you rate that?
I think we have many customers, so we have many numbers, right? Which would scale from, I think, 1 to 10, right? So I think it depends where we are in the journey with a specific set of use cases and user stories. So we have many success stories as well, and we have many challenges as well. But I think the key is that as long as you're operating in an environment where business is partnering with you on that journey, then that number doesn't mean anything, because that's a collective success or a collective failure.
Would like to take?
I think, for me, first thing, I'm new to BP, right? So you can't ask me how happy are BP folks with me. But that thing aside, I think it's a mixed bag, as Saad said, right? So I think the way I have seen things happening over time, again, there are a few things which you'll keep hearing from me again and again, right? It's that sweet spot which you need to hit between the amount of effort you're putting and the value you're generating, right? And it's when you are able to define and achieve that value, right? That's where things happen. So, I'd say, I think, have we done things correctly? Probably not over time. Like 15 years has been 15 years of learning what not to do, right, for me. But I think while we have done that, we've also figured out what works best for people as well. So I think, again, it's a mixed bag, but I'd say be more value focused, right? Talk in terms of what are the value of, you're delivering. And once you start doing that, right, instead of just building a technical warehouse, start building something which adds value incrementally, and that's when, you're on the right trajectory. That's what I'd say. Thank you.
Yeah, so for me, the customers are like not only the in-house customers, but since we deal with multiple customers. So I have seen the experience of those customers increasing, somewhere between 6 to 8 over the time. And it happens just because of, one thing I have seen in summary is they need to unlearn a lot of things, how to do things onto the cloud, and don't over-engineer things, right? So the people who all came from the on-premise area, a whole lot of legacy area, they have to unlearn the way they have to act upon the cloud, right? And when they accept it, adopt it, their experience improves, right? So that's the biggest thing, and the experiences that we are able to seek to the customers over the time. Again, not like a first year. Even the TCO, etc., you calculate over the year, not like first year, second year, third year, right? So over the time, I have seen customer experience improving from between 6 to 8.
Thank you so much. Do we have time for a couple of questions, Yash? Or we should take it over networking? Okay, I'm sorry, we run out of time. With that, I would like to thank Saj, Rahul, and Neeraj for their valuable insights. You can ask them questions, you can catch them during the networking lunch. Thank you so much for joining us. With that, I would hand over to Yash for the next session. We have planted a tree on your behalf. You can just scan the QR code and you see the plant growing. It's planted in the farmer's farmhouse.
Good afternoon, everybody. Welcome back. So I know we all had a heart full and tummy full meal, and I'm hoping that we will have a lively audience today, and that's the only thing that motivates us to, stand here and talk, and that too with our speakers as well. So we will start in a few minutes, but I thought, why not just shake things up a bit for all of us? It's always better to have that after a hearty meal, right? So I'm just going to talk for a few minutes, and then we'll have our sessions officially started. So I just wanted to check with you guys, how has been the day so far, so good? Anything that really stood out for you, something that you really liked as part of the parallel tracks that we're doing, and anybody would like to share? Don't tell me only about the food, yeah? I don't want to know which dish was your favorite. I know we had a good meal today. But anything else that you're looking forward to? Maybe post-lunch sessions, something that you're really looking forward to? Anybody? Don't hesitate. Yeah, please. Yes, absolutely. Absolutely. So I'll just repeat your question for benefit of others. So you just asked me that, he's here in this hall and there are other sessions going on parallelly. So how do we get to know about those sessions? So we have recordings and we are also streaming live on YouTube. So Nasscom Member Connect is a handle on YouTube, and you will be able to find all the sessions there as well. So they are happening, there's a live stream that's happening as we talk. So that is available to each one of you. Maybe later on, go back and have a look at some of the sessions as well. Right, anybody else want to share anything? How many are from the core tech side today? Good show of hands, yeah. And from the business side, innovation conclave, business side gets underrepresented, huh? But that's good, right? We need to have tech guys come out more for such conferences. So, and that goes with the theme of the session, right? Great. So I think we are on time now to start. Yeah. Maybe a minute away. But we will give the leverage of time to our first speaker. We will give you 2 extra minutes. So let's get going. And to kickstart our post-lunch session today, we have Dhanashri Chauhan, who's from GitHub. And the topic that we are going to talk about is going to be DevSecOps. So Dhanashri, why don't you please come on stage while I talk about her. So Dhanashri is Senior Enterprise Advocate at GitHub. And she's going to talk about how you can integrate innovation into business strategies and how you take that whole innovation step forward. So on that note, I'm going to pass over the baton to you, Dhanashri. All yours. Thank you.
Thank you. Can you hear me? Both? Okay, first of all, oh my God, is there an echo? You're fine. Okay, I'm hearing my own echo. Sorry about that. Hey guys, thank you so much for attending. I know, post-lunch sessions are always difficult. I had told the organizers I don't want a post-lunch session, but here we are. So please, I would love to see some kind of expressions. If you're not understanding anything, frown at me. If you're understanding something, smile at me, okay? It'll be really helpful. So it's not projecting. Show of hands, how many of you know GitHub here? Oh, wow. So maybe I can learn a thing or two from you guys. But I think today's topic is really, really cool. This is not supposed to be like a GitHub sales pitch, right? I want to talk about innovation and DevSecOps. So, yeah? Yeah, maybe 30 seconds. No problem, no problem. Any show of hands where you guys are from Pune? Very cool. Okay, so I'm a proud Punekar as well, now based in Bangalore, but I hope to get some support from the Pune crowd here. And thank you for those folks who've traveled all the way here. I know airport, I left for my flight like 4 hours before, so I wouldn't miss this. So I hope this is really useful. Another thing is, I hope all of you take at least one thing new that you've never heard before, even though all of you are GitHub users. And I would love to hear some questions after the session. So please feel free to come and approach me and we can talk, okay? I met the Infosys guys here, and they are actually one of our largest clients here in India. And I think one of them was, oh, this is great, GitHub is great. Other person was like, GitHub keeps talking about security advisories. Please stop this. I was like, hey, if you're coming to this session, at least say good things there, okay? No complaining in the session. We can talk later. All complaints outside the room. How's the session been for you so far? Yeah? That's awesome. That's awesome. I heard a few panelists, and I think it's very cool that everyone seems to be talking about innovation nowadays. And digital transformation is like the key word, right? I mean, this is such a jargon and such a buzzword all the time. But the important thing is, how do you actually bring that into your practices? That's what I want to focus on. And it's amazing that you all know GitHub already. So, I can touch upon how we are trying to do that at GitHub, and also some other practices that you can cover, okay? So as soon as I figure this out. You want to do some breathing exercises with me? No, I'm serious. I have like a, I'm feeling something here in my tummy. Count of 5, okay? Please. Okay. Oh, I'm feeling calmer. 3 more, guys, 3 more. Okay, that's great. One last one. Thank you. Okay, we're getting here somewhere now. No, cool. Any session you guys were most excited to watch? Either it's happened or you're going to watch it today? Oh, really? Thank you. I hope, oh well. No pressure, huh? Yeah? Okay. That's fine, that's fine. Yeah. So I already covered what I wanted to talk about today, because all of you already know GitHub, which is fabulous. So let's go from there. The funny thing is, I came here and I saw that the delegate bag sponsors were Atlassian. So they're like direct competitors. I was like, so they may not be very happy about this, but well. Again, promise no GitHub sales pitch here, but we would love to hear from you as well about how you are using GitHub. Which companies are you from? Oh, nice. Sorry? Oh, nice. Wow. Where are you guys coming from? Oh, Pune? Nice. What about you guys? Alicia. So you're test automation. Nice. That ties in very nicely with GitHub. What about you? Sir? You guys? Product engineering services. So I started my career actually with persistent systems. So of course they're huge in Pune. I was lucky enough to be in the US for about 14 years. So I spent a bunch of my time in professional services. John Deere was one of our largest clients. I worked at Whirlpool. We had someone here from Whirlpool, and it was amazing. I think going to these different clients and actually learning that environment from scratch, that is really, really helpful. I was focused solely on IBM security products. So I started my career with identity access management. Thank you. So, thank you. So going from there into something like DevOps and DevSecOps was an eye-opener. Because with legacy products, the innovation can be a little stifled. So something like GitHub is just fabulous and eye-opening. Where are we? Okay. Yeah, so this is what I want to cover. I mean, I didn't want to do that normal infinity curve. All of you know this and seen it 100 times. So we don't want to do that, okay? So what we are seeing today is the future is more innovative than ever, right? It's being powered by apps which are enabling this innovation. So think of AI-powered sales tools. Think of hyper-personalization of retail. Today, even if I talk about a pair of jeans, Insta and Facebook and everything floods a bunch of things, right? So this is all personalization. These apps that we're looking at, they are cloud native. They are intelligent to what the consumer is asking for. They are iterating on other people's work. And GitHub is a large part of that, of course. But they're also hyper-focused on customer needs, okay? So what we are trying to do is, with modern engineering methods like DevOps and DevSecOps, we can power these apps. Now, at the heart of all of this is the developers, right? They are the ones building the app. But today, this is how most traditional security and development teams look like, right? So a show of hands, if you guys were working on a feature sprint and your CISO came along and said, hey, there was a vulnerability in that piece of code you wrote last week, now stop everything and go and fix that. Show of hands? Thank you, right? So we want to move away from this, right? This is not productive for anyone. This is what we want it to look like. So with DevSecOps, the development, security, and operations teams need to be aligned towards one goal. And that's what's going to lead to innovation. Well, how will this lead to innovation? Let's see a few examples, okay? So we've all heard of this. Equifax happened. What happened is they could have prevented this breach long before if they had just patched the struts vulnerability which was there, okay? But today, industry data is showing that 70% of vulnerabilities are open or not remediated for up to 30 days. Let that sink in. 30 days. An average time it takes for a developer or an attacker or a hacker to breach, someone or to kind of take advantage of that vulnerability is 3 days. And with something like this, it's going to take you 30 days. That's ridiculous, okay? So that's what this is something that we want to avoid, and that's why security is so important. Another thing is we've heard of SolarWinds, right? So Sunburst, which was the backdoor which was used in the Orion systems, was distributed globally to clients via an update. Now imagine this, the company itself is breached, and now you're spreading it across to all of your clients. That's terrible, right? The thing here is Microsoft was able to detect, and they were able to open source some CodeQL queries to this thing they named SolariGate. And I'll talk about CodeQL later, but the key takeaway here is today security is not the responsibility of one person, one organization. If they had not open sourced this, imagine a company working in a silo trying to fix this, right? How much more the attackers could have then taken advantage of this if they had not open sourced something like this. We've all heard of CodeCorv. We've heard of Log4j recently. All of this is basically that the community cannot work in silos anymore. Your teams cannot work in silos anymore. You all have to collaborate. This is a very interesting example. So this I took was, look, this is not a classic vulnerability per se. This picture is of the Mars Curiosity mission, the Mars Curiosity rover. And this was in development for multiple years before they actually released this. And you can imagine with an organization like NASA, the kind of strict testing that they would have done before this was released, right? And yet the JPL lab at NASA, which was the Jet Propulsion Lab, they found a mission critical bug while this mission was en route to Mars, okay? Now, what they did was they reached out to the GitHub security team, and the GitHub security team was able to come in. They were able to run a few basic queries, again CodeQL, but they were able to find 30 other issues within this code base. And the JPL team actually fixed this on the fly, literally, while this mission was on the way to Mars. So this just gives you an idea, not just your classic vulnerabilities, but like design flaws need to be taken care of. Okay. UPI, example close to home, right? I use it personally multiple times a week. I use it for paying groceries, to transfer money to my brother or my, my cousin. Wow, okay. The main thing is, I think what's interesting is, just to give you an idea of the scale that we're talking about, last year, or 2021, globally, the real-time instant payments that were made, of that, UPI accounted for 40%. So 48.5 billion transactions were made using UPI. Now, that's mind-blowing numbers, right? Imagine the kind of scale that something like this is bringing to us. And UPI is enabling financial inclusion. It's changing the socio-economic fabric of our country, right? I live in Bangalore, in Kormangala, and literally the coconut seller is accepting UPI payments, right? Everyone there, in fact, if you carry cash, they're like, ma'am, please UPI app kholo, okay? So that's where we are seeing that in a highly regulated sector like fintech, why security plays such a key role. Okay, so we looked at all these examples. Now, how do you actually bring them to your own practices? If you guys already use GitHub, this is like preaching to the choir, but I'm going to try some, okay? I think culture and a security-first mindset is key and paramount. So what used to happen earlier is the development team would code something. At the end of, say, 3-4 weeks, they would deploy it, and the security team would come in, right? Now the security team is generating an Excel sheet, which they're sending back to the poor developers. Now the developer has moved on. They've moved on to another project. They've moved on to another team. They have no idea this vulnerability is referring to which line number. What file is it referencing? The context is lost, right? So it's very difficult if you don't have the context for the poor developer to fix. And that's what DevSecOps aims to solve. So with DevSecOps, you're basically trying to get the security teams involved in the development phase or early stages of development. The security first mindset, remember the picture of the kittens fighting? That's what we want to avoid. We don't want that with something like this mindset. It's not us versus them. It's not security versus development. Everyone needs to collaborate together, okay? This, I'm sure all of you are aware of. Today, modern engineering methods, modern engineering systems have 80 to 90% of open source. In fact, we have some clients who have entire teams dedicated to finding the dependencies and vulnerabilities in your open source code. Today, you cannot not have open source, right? You want to innovate, you want to build on what other people are building, but at the same time, you're involving and introducing all these thousands of developers within your software supply chain. So you need now practices and tools which can take care of these vulnerabilities as they are being introduced, okay? The second thing is inner sourcing. So inner sourcing is basically the culture of having, say, the large-scale open source projects, making sure that the best practices there are followed within the confines of your organization. And that is really the key. The third thing here that shows is typically we are seeing now that the ratio of security researchers to developers in any given organization is almost 1:100. 1:100, guys. That's crazy, right? So imagine the amount of code that is being generated and the number of security people who can now look at that code and see what is vulnerable. So what we need to do now is empower developers. So how do we do that? A key tenet of DevSecOps is shifting security left. If you see this arrow here, we are moving all the way from post-deployment into the development phase. And that's where you want your development to move. So we've heard shift security left a lot. What it means is that try to get your security practices as early into development as possible. In fact, you can have, say, a security person involved even in your design phase, even before you start developing something. And that's really important here. Another key piece here is if you find a vulnerability in the development phase, it's much cheaper and much easier to fix it in development than if you are in production. So you can see the dollars quoted here, right? It's almost 100x cheaper. Also imagine the minutes. Like I said, the developer, while he's writing the piece of code, if I get an error now saying, hey, you're introducing a log4j injection or a SQL injection, I'm going to not commit that piece of code, right? Versus after, say, 5 weeks, if I get that report saying, hey, now fix this now, it's going to be very difficult for me to understand where I need to fix this, okay? So we'll look at some other coding practices. I'll just give a few examples of this. Just a quick check. Am I going too fast? Fine? Thanks. So securing developer machines. Now you can have cloud-based machines as well. So what we want to do here is, say, employ the access or least privilege access principle here. So even if that developer machine is hacked, the blast radius is really low. So this is not affecting the team member, the organization, and their clients, okay? So that's something you need to do here. You need to secure your DevOps pipelines. What I mean here is that only authorized actors and authorized pipelines should have access to your supply chain. They should not be able to make any changes, especially in production. The third thing here is hardening access to code base. So as a general rule of thumb, we say that everything should have a maintainer. When you have a maintainer, the chances that that piece of code has gone, say, it's archived or it has a vulnerability which no one is detecting, that goes down significantly. Another example is, say you can employ branch protection rules. So by branch protection, I mean, this is your main line of code, right? Then you're creating feature branches, merging it back into the main line of code. So at this point, you need to make sure, suppose I am a developer, I am writing something, when I merge this back into that main line of code, I have at least 2 other people who will review that piece of code before it goes back, okay? So that's called branch protection. And this is not something that you tell your team, okay, make sure that there are 2 reviewers. That's not going to happen. You need to have processes and controls in place at that point. You need to monitor your developer cloud for abnormal activities. So suppose you have a leak or a credential which has leaked out, you need to send instant notifications to your developers so they can fix it right then and there. You need to harden pipeline access. So we all have heard of identity access management scans that we run, right? Again, this ties back to least privilege access. So only people who need access to that particular system, code base, should be given access to that. Another thing is multi-factor authentication. I mean, that's become so common nowadays. Even when I log into Gmail, for instance, I get an OTP, right? So multi-factor authentication is very, very important. The third thing you need to do is have endpoint protection enabled. So what happens is zero-day malware, for instance, can be taken care of. I'm going to let you read this. I'm sure many of you have seen this CD comic. It's one of my favorites, Bobby Tables. So I'll give you a second to read this. So this is funny, right? But it's actually the reality today. If you don't have security when in your database, your inputs, right? It's going to be very difficult for you to then fix it later on. So this ties back into design, into pre-development phases, and bringing security right there. I'll move on. Okay. Now let's think about developer workflow. When we were talking about Bobby tables, this is exactly what we mean. So there are different stages of when a developer is actually writing their code, right? It can be pre-commit. It can be your CI/CD, but it can also be post-deployment. So let's just look at all of this one by one. So by pre-commit, I'm not going to read all of this. Essentially what we are saying is start thinking like an attacker would, right? So look at your threat landscape. We have some clients who would play, say, war games. So you can have a red team, a blue team, maybe someone is being an attacker, someone is being a defender. So it's a fun way to bring this culture back into your system and your mindset where people understand that what they're writing can be a cause of potential breach. Peer reviews, sorry. One thing I would like to notice here. So like I said, branch protection rules, where you want to make sure there are at least 2 peer reviews. With peer review, what happens is when you have multiple team members and you have peer reviews, they want to make sure that this person who is writing the code now is aware of the risk that can potentially be there in the code. So your team is aligned. And again, ties back to security first mindset. Let's talk about the CI phase. And I'll glance over this because I'm going to talk about it later. But basically what we are saying here is as soon as your code is written, it's uploaded, say, to your GitHub repo, or as soon as a secret is being scanned, as soon as that piece of code is written, you should have, say, SaaS tools, DAS tools running. You can have credential tokens running. So for instance, these credentials could be, personal access tokens. They could be database keys. They could be, say, Terraform keys, anything like that. In the deploy phase, infrastructure as code is, again, another jargon, right, that we've heard so many times. Basically, cattle, not pets, right? You try to scale as much as possible. But with IAC, then you need to make sure that you are securing your policy config files as well. Because now that piece of code is going to lead to multiple deployments, because that's the way it's configured to do. Then you can have security scanning tools, make sure that your cloud configurations are taken care of, and make sure security acceptance tests are running at every phase here. And of course, this does not end at the time of deployment. This is continuous process. You have to keep monitoring for threats. You need to have blameless postmortems. Let's face it, guys, security for everything that we are saying, beep is going to happen, right? We're going to have that in our security chains. So what we need to make sure is, after that happens, let's not blame each other and see whose fault it was. Instead, let's do a root cause analysis. Let's figure out what caused this to happen in the first place, and then make sure that this does not repeat itself. So coming to GitHub tools that can help. Again, I'm sure maybe most of you can educate me more. Been at GitHub for a short while, but we'll see. Now, GitHub has a lot of offerings. I'm sure you've all heard of GitHub Copilot. It's our AI pair programmer, But I think these three made sense for this talk, especially because we are talking about developer environments. We are talking about automation when it comes to innovation, and we are talking about advanced security, of course. So GitHub code spaces. How many of you know GitHub code spaces? Okay, good. Very few. So let me just go back to the basics. GitHub code spaces is basically your entire development environment in a browser. Okay, think of it as an IDE in the browser. Now, why did we come up with something like GitHub code spaces? One is, when you have a new person joining the team, how much time does it take for them to be productive? Any figures here, like hours, days, weeks? Any numbers, guys? Weeks, right? Exactly. Now, because I remember this from previous roles as well, right? Now imagine this person has left, another person has joined, this cycle repeats, right? This new developer thing, or people coming in and out of teams, that's not just the only thing. Now, this same cycle repeats for your architects. Am I boring you? Okay. Your architects, your team leads, your project managers. So this just it is so time consuming, right? It's going to be a real pain to get your developer environment set up. So forget that they're even writing code. Even before that, they don't even have an environment to write in. So that's what GitHub Codespaces aims to do. The other thing is that you can have policies which are now common across your team. So this person, one developer is not installing one extension. The second person comes in, they install another extension. With a policy as code that we keep talking about as code, you're basically making sure that everyone in your team has the same developer environment set up. Another example I can give for this, the reason for building this in the first place was, imagine that you're working on a client project which has very niche requirements for how powerful that particular machine should be, right? Now, one is procurement is going to take a long time, but after you're done coding and testing, that machine is lying around just sitting idle, right? You're wasting a lot of resources and money. But with something like GitHub Codespaces, you can configure your machine however powerful you want it to be, and you can build it up and tear it down instantly. So these are cost savings that we're talking about. So to give you an example, this is how your GitHub repo looks like, right? So this is my public repository. This is the main page where a developer would spend the maximum amount of their time. I have a button here called Configure and Create, and instantly I have an in-browser pop-up come up, which is basically my entire development environment, which spins up within a few minutes. So that's very, very powerful. Again, I think this basically just shows that the look and feel is very similar to Visual Studio. So this is something that developers are already familiar with. So there's no extra training required for this. GitHub Actions, so if you've worked with, say, Jenkins or something like that, so this is basically our automation platform. So what we try to do is give developers a familiar enough experience so that they are not wasting time setting up their CI/CD pipelines, but they are building quickly, and they can have those CI/CD integrated in the same place that they're writing code, and that's very powerful. I don't say it, Pinterest also says this. They saw 8x efficiency increased as compared to their previous CI tool. There are a couple of reasons for this, and I'll get into that. So GitHub, one thing is that the way actions are configured, we use something called yet another markup language, or YAML files. So your developers don't have to learn something custom. Okay, they can get started very easily. Second thing is, again, power of community. So we have a GitHub marketplace, which is free for anyone to use. Okay. Now today we have 14,000 actions pre-published. think of these actions as Lego blocks. Any of you played Lego here? Yeah. So basically take that Lego block and then you build your Mario Kart, build your GitHub universe, build whatever you may, right? Essentially it ties back to innovation. You take something that the community has built, is being verified because you get a verified badge, and then you can use it to build something of your own, which is going to market faster. Now, there are 3 kinds of actions that are typically published on the GitHub marketplace. One is, of course, we publish our own actions. Second is, think about cloud service providers like AWS, GCP, Azure, of course, but DigitalOcean and all. So they build some actions which are published here. So the OEMs themselves are publishing actions on GitHub marketplace, right? I have not seen that with any other tool. The third kind of actions are the community. So today on GitHub, we have almost 80 million developers, okay? 80 million is more than double the population of Australia. So you can imagine that the kind of community support that you're getting. In fact, we've heard that when clients start designing and building something, chances are that someone has already built it and they've already worked on it. So this is again another way of going to market faster. These are some of the things, like I mentioned, these are all the actions. So in GitHub Actions, the OEMs, the first-party integrations, and then the third-party integrations, which is the community support that we have. Integrated security is GitHub Advanced Security. This is the last piece of it. So here, now, this is the GitHub flow, okay? If all of you in development, this is your main branch of code that I keep harping about. Keep it safe, keep it secure. You need to make sure with DevSecOps that people are able to experiment without fear of failing, right? How do we do that? You make sure that they can create a new branch. So think of this as a sandbox environment. Now this developer can play in this as much as they want without affecting the rest of the team, right? So after you create the new branch, I can make some change, and now I can send it out to Amit, saying, hey, Amit, I have opened a pull request. Please come here and collaborate on this. When he gives me some feedback, GitHub gives you a space to have discussions. So pull requests, issues, discussions. You can use all of these to collaborate further. And only when this has passed your entire team's okay is when you merge it back into your main line of code, okay? Now, how amazing would it be if you're able to now integrate security within each step of this, right? That's very, very powerful. So let's see 3 of these. Code scanning is basically where you're making sure that you're scanning your code base for vulnerabilities. At GitHub, we basically employ an engine called CodeQL. QL stands for Query Language. We got it as an acquisition of a company called Semel in the UK, and I believe there were researchers in Oxford University who worked on it for more than 13 years. So it's a very powerful and tried and tested tool. So with CodeQL, what we are trying to do is before, as soon as your code repo is dropped into GitHub, this code scanning starts taking place. The important thing versus other SaaS tools with CodeQL is that it treats your data as code. So it's not doing like a pattern matching or a regex matching. Because with other tools, if you do a regex matching, I have a piece of code in comments, it will still show up as a vulnerability. Or if I have a method, which is really crazy, but I'm not really calling it anywhere, it will still show up. So now developers have these false positives come up. So that's very, very tiring for them. And that's what code scanning aims to reduce. So that false positive goes away, or gets reduced at least. Secret scanning is making sure that secrets, I'm sure all of you at some point in our careers, we have put in some AWS secret, some database secret into our code base. Extremely damaging if it's found, very easy to breach because there are scans going on. Hackers have these scans of all these repos where they can look at something like this. So with secret scanning, what we do is not just the Git head, but we are looking at your entire Git history for these patterns. Now we have almost, I think, more than 40 plus secret scanning partners so we can detect, say, HashiCorp keys or AWS credentials or things like this that we have, which are, of course, the patterns, but you can define your own custom patterns as well. So that's why it's really powerful. Security overview, now think of this, when an admin comes in or a developer comes in, you want a single pane of glass view, right? So those code QL alerts which were generated by either code QL or another third party, which you can integrate with GitHub, you want them all in the same page, right? And I'll tell you why that's important. So today we have studies which show that if a developer is working on a piece of code and they change context, it takes them 23 minutes to get back into flow. Imagine the kind of time lost, right, over weeks and days. So that's what you don't want to do. So you want one single tool. As they're writing code, your security vulnerabilities are showing up, and you have a way to fix it right then and there. So I have 3 client examples here. The main thing I want you to look at is the impact, okay? With HashiCorp, they save 6 to 9 months of project development time just with automated security vulnerabilities. I mean, imagine guys, innovation, we talk about innovation, but what is innovation? You're giving time back to the developers, right? You're freeing them, instead of doing security things they don't want to do, not interested, they could focus on doing the coding which they wanted to do, right? So this is very, very powerful. Datadog, there were almost 250 leaked Datadog keys which were found in 1 quarter. 1 quarter, 250 keys. So imagine now if they had gone into a client base, right, and an attacker or a breacher who would have found it, a hacker would have found it, it's extremely difficult then for a company's reputation. And that's what you're trying to prevent here. Pinterest, I talked about Pinterest earlier, and it was a 8x, right, reduction in build times. They have another example here. So 90% decrease in build time after moving to GitHub Actions, CI/CD. And again, hundreds of security vulnerabilities caught with Dependabot. Any of you know Dependabot? Okay, so think of this as a bot which is running in the background. It's scanning for your manifests, your POM files, okay? And suppose what it does, it's comparing this versus the GitHub vulnerability advisory database, okay? Think of it just as a database. It's trying to look for any vulnerabilities. Now suppose, for instance, this log4j version, say 3.14, just making up numbers, had a vulnerability. It will look at the next closest number which does not have a vulnerability. It will automatically open a pull request to fix that, saying, hey, from 3.14 now move to 3.14.1, which is now where this is fixed. We don't merge this automatically because we give the control to the users to make sure that they have full control over their repo. So just to summarize, DevSecOps is continuous and ongoing. It can be very challenging when you first introduce it to your teams, but think of it as a mountain with the right tools, with something like GitHub security scanning, where everyone on the team is now confident that that piece of code has gone through all the tests, it's vulnerability free, and I can build on top of that. With the right tools and practice, you chip away at it little by little so that this becomes part of your culture. Thank you so much, guys. Thank you for listening. You've been wonderful. Thank you. Oh, boy.
Thank you, Dhanashree. Very enlightening. We have a small token of appreciation for you. So we planted a sapling
oh,
on
that's
your
amazing.
behalf.
Amazing. Thank you.
So that's a certificate for that.
Thank you so much. Hey guys, just a show of hands. Did you learn at least one new thing today? Yes, thank you. Thank you. That made my day. Thank you.
Thank you so much. Great. On that note, let's move on with our agenda. Hi. So on that note, let's move on with our agenda. And our next session is going to be a masterclass on operationalizing AI and ML systems. Now, AI and ML systems help in achieving smarter and faster workflow. We all know that. This unique application allows easy data optimization and saves resources and time. AI and ML systems enable automation in the process, which automatically guarantees accuracy and precision at each step. Today, we are going to talk about that. And while we have Reshma being set up, I am quickly going to talk about her, and then I'll hand over the podium to her.
remote.
Great. So Reshma, thank you so much for being here today. Reshma is a senior data scientist at Persistent Systems. And over to you, Reshma, so take us through this whole journey. Thank you so much.
Thank you. Thank you for inviting me here for this talk. Is my voice audible? Am I audible here? Yeah. Okay, good. Okay, so yeah, good afternoon, everyone. I'm Reshma Godse from Persistent Systems. I'm a senior data scientist in AI lab there. And we do research on latest technologies and try to help customers in better way. So my focus areas include time series analysis, recommender systems, and the today's topic, which is MLOps. So I'll start with basically why we need MLOps, what is MLOps, then we'll go through a few of the architectural patterns and concepts in this domain which help us here. Then a brief about responsible AI and how we can include that as part of our MLOps framework. And in the end, if time permits, I think we'll discuss how typical progression of your MLOps culture takes place in the organizations. Okay, so this is a picture from a very famous research paper from scholars at Google. Many of you must have seen it. What it essentially says is that in real world machine learning systems, the amount of ML code is small as compared to the surrounding infra that is required to keep operating successfully in production. And as you can see, there are so many boxes here, right? So in absence of proper architecture, many technical hidden debts may creep in, which eventually need to be addressed, and they affect the effectiveness of your overall system. So, but with MLOps, I think there are some architectural patterns which help you create very nice abstraction boundaries, which is kind of difficult with ML systems, but we'll see how it helps here basically. And that allows teams who are working on the machine learning systems to collaborate effectively. And each one sort of knows what they are supposed to do. They don't step into each other's roles and then collaborate effectively. So MLOps is not just a set of tools stitched together to create one framework. You should think of more as a engineering discipline that needs to be set in the team. And when set properly, it helps to streamline the journey of your models that you're going to create from its ideation to production. So essentially, it's like DevOps for machine learning. But there are certain aspects of machine learning systems which need to be handled differently. As in, model development is more of an iterative process as compared to your traditional software development process. So though the experiments that your data scientist is going to carry out, they need to be tracked or they need to be handled differently. And for example, when you deploy a system in production, in addition to your basic monitoring, you also need to monitor model performance, because even if your system is like working at its best, if the model performance has degraded, then there is that system essentially becomes unusable. And in addition to that, there is whole angle of responsible AI, which I'll discuss little later in my presentation. Because of this, it is like slightly over and above DevOps, and it needs some other specialized patterns. So if you have an effective MLOps system, MLOps culture, okay, sorry about that. Hello? Yeah, I think it's good, okay. So if you have an effective MLOps culture, then it helps bring clarity, role clarity to various teams, like your data engineers, your data scientists, then the DevOps engineers and domain experts to sort of know what they're supposed to do, so they don't have to go into someone else's shoes and do their job. And it helps in rapid development of your models, which helps in staying relevant in this changing world, eventually increasing your overall ROI of the system. So the way we'll do it is, I'll take an example use case, very simple one, and then we'll see how these patterns help us along our way to deploying the model in production. So this is a typical life cycle of a model. You start with a problem definition, then there is a data, you hunt for data, there is data engineering, feature extraction, then a model, there is model training part which gets deployed in production, which is monitored, and if the performance degrades, then eventually you go back to retrain. You have to retrain the model, which takes you back to your data phase. So in this overall cycle, these are various concepts and patterns that we are going to discuss, and they help in certain way. So let's focus on problem definition. So the problem is very simple. We are working for a bank, and then we want to develop a model to assist our loan officer. And the model has to predict whether a given application is approval worthy or not. So 1 for approve, 0 for reject. And we can think of two ways in which this system could be deployed. One is for online inference, where Your bank has a web interface, web app, and you just put a slide, a button next to your web application. The loan manager clicks on that button, the web interface contacts your model, which is sort of deployed as a web service. You get the prediction back, show it to the manager. So this is like online inference. Or you could also think of this as a batch inference, in batch inference way, where you don't have to create a microservice for your model. It is executed as part of your scheduled script. It processes a batch of load applications and stores the predictions in your database. Okay, so now that we have understood what the problem is, now let's hunt for data, and then we want to leverage the historical data which is available with the bank for our model training. And these are going to be typical list of features that we'll end up using. So if you see, it's like there is a customer demographic section, then of course customer financial profile, which is very important, and details of your loan application. But out of all of this, let's say your bank doesn't calculate and store monthly average balance of accounts that your customers have in your bank. So then what do? You need to write custom code, and that custom code has to take care of all boundary cases. There has to be testing and everything involved. So this is one piece of custom code. Then your data is going to be spread across multiple tables, probably like different systems as well. And you need to actually write connectors to pull data from multiple systems, join them on the customer ID. So there goes another piece of custom code. And you have to make sure that the same consistent feature set is generated while generating a training set, and the same piece has to execute when you're creating features for your serving set while you're doing the prediction. So there are so many hassles, right, for a data scientist. Imagine if there were a system where data scientists could have just said, okay, give me demographics information, give me customer profile, then give me some transaction, last in transactions, without worrying about where the data is being sourced from, whether it's coming from streaming source, batch source, like doesn't have to worry about it. Then for the derived features, like this is a very simple example, but for many of the derived features, the data scientist doesn't want to worry about how they are calculated, how the boundary conditions are taken care of. So that is what feature store gives us. So this is an image which shows Feast, which is an open source feature store. And as you can see, the data is being sourced in from streaming sources, batch sources. Then there is a second box, which is transform box. You can define transformation pipelines, which help you aggregate that data, create different entities, define the join keys, create your derived features and all of that. And the data engineer is best at doing this job. So the feature store should be typically owned by a data engineer who knows how to pull data from various sources and make it available. And data scientist doesn't have to worry about anything, just pulls the data for training, and the same data set consistent flows in for your inference, like real-time inference as well. So that is how feature store helps you. But how do you know whether you really want you really need a feature store or not? As in, feature store is anyway going to be a parallel deployment to your data warehouse, so your main source of data. So it's going to be like another set of resource that you want to invest in. Foresee that there are going to be a bunch of models you will create in future, which are likely to use similar set of features. There's going to be, there is overlap. Then investing in a nice feature store a little ahead of time proves very helpful. So that's the overall experience. Okay, so now in our bank, let's say Feast was deployed, our bank was very nice, and data scientist is very happy, just got all the features. Now comes model training. So we start with like one typical, very simple one, random forest, and we give one set of hyperparameters, and we have two trainings, two sets of training data. We use first one set of hyperparameters, we get model 1. Then we are not happy, we want to probably experiment more. We get second set of hyperparameters, we get model 2. We change the algorithm, we get model 3, model 4. We go for AutoML, we get model 100. And that's how data scientist ends up doing like lots and lots of experiments, and they need to be tracked. So experiment tracking is a process of saving all your information about the model, because out of this all 100 experiments, you never know which one is going to get to production. So which one is going to be your best model? You never know that. So everything needs to be tracked. So what can be tracked? Just now, like Dhanashree mentioned, source code, of course, reference to source code, scripts used for training your model, then reference to your training data and validation data, and so on and so forth. Then the environment configuration, very important, library versions, then algorithm details, hyperparameters, performance metrics, like many other things. You can track almost anything. But what should be tracked? Everything that you require to reproduce that model on a different environment probably, but that needs to be tracked. And that helps with an angle of reproducibility, which is an important angle of responsible AI. You want to be able to reproduce that model in case you face issues in production. You want to say that, okay, I can reproduce this result on the training data and see these other results. Everything that your model risk manager, and I'll talk about this role a little later, everything that your model risk manager requires to approve that model in production should be tracked. And everything, of course, that your DevOps engineer requires to deploy that model in production should be tracked. So all the library versions and everything needs to be tracked. Now this is a nice UI of ML flow tracking server, and as you can see for our loan approval prediction model, a bunch of models have been logged here. And there is a nice search box which allows you to search through all the models based on some tags, based on some hyperparameters, algorithms, or whatever. And it also allows you to sort of sort these models basis your performance metrics or any other feature, any other thing that you think is important. So that's what experiment tracking is all about. And again, coming back to our use case, let's say that this light JVM, the first one, it has good, like decent performance metrics. So let's finalize that for production. And we want to deploy this one in production. So we as a data scientist now want to share this model with other teams for deploying in production. How do we do that? So there comes model registry. What do we do is from experiment tracking, the best model gets registered to model registry. And model registry is a way of declaring that under this experiment, loan approval prediction, this is the production grade version model available right now for your consumption. And all the downstream apps can basically use that model. So it is like a central storage for all your production grade models, for your subunit, for entire organization probably. But all the models that your teams have built so far, they should be logged here so that tomorrow if someone else wants to create similar model, that data scientist can simply come to this model registry and check if some such work has been already done or not. Then it bridges gap between experiments and the production activities, the deployment activities basically. So model registry is not just to declare models in production. Okay, it helps a little more as well. So it helps with the governance of the models. As in, like we'll go back to our GitHub example. So we can compare it with our source control version where we create pull request, then there are certain checks made on the pull request, and then the code gets approved for merging. So similarly, model registry also helps us to set up similar workflow for models. And why do we need such workflow? Because probably, like me, I as a data scientist have declared that this light GPM is the best model, I'm getting best performance metrics on it, so use this. But we never know what kind of data was used for training the model. As in, like, as a data scientist, I know, but there is another role called model risk manager who sort of has holistic view of your business and who knows what kind of problems you may run into if the model gives biased predictions, let's say, based on gender, based on caste, whatever. So that model risk manager is a very important person, and that has to approve the model in production before it gets deployed. So now this is UI of model registry of Databricks, and as you can see, so many models have been already logged there, and this one is ours. So loan approval prediction, which we created just now, is logged as version 1, approved in production as well. So now comes deployment, and we have decided to go ahead with online inference. So for now, let's put down our hat of data scientist and let's wear a hat of DevOps engineer. How are we going to deploy it? We pull the latest model from registry, we create microservice out of it, and the web app is updated, and it fetches the predictions from the model and shows it to the your loan manager. So deployment is done. So now, do you think our job as data scientist and as DevOps engineer is done? No, of course, because even though the model was good on some training data, we want to ensure that this model keeps on operating to the best of its abilities in production as well. And so what can change in production? Like, there are so many things which can change, and we'll discuss how. Now this plot shows that this is the line decision boundary created by the model, and these are 1 and 0 based on the ground truth. So as you can see, this is the production data, and you can see that very few greens are on that side and very few reds are on this side. So model is still, the decision boundary which the model learned on the training data is still holding like good. It's doing a good job here. But how did I draw this plot? Because I had access to ground truth. When the model gets a request for prediction for a particular loan application, you will not have access to ground truth, and in many other use cases as well, you may not get access to ground truth so early. So when ground truth is not available, you're essentially flying in the dark, and you don't know if your model is performing good or not. So then what can you do? What do you have access to here? You don't have access to ground truth. But in production, we have access to the incoming request, the incoming feature set, and we have access to the outgoing predictions which the model is returning. So essentially, you can track feature distribution, You can track prediction distribution. Prediction distribution is also important because let's say for spam ham case, you trained on a data where there was 70-30 distribution, 30% being spam. And in real life, you see probably 90-10, very less spams. So there is suddenly a shift in the predictions which are written by the model. You can track bias and explainability as well, and I'll talk about that a little later. And when you have access to ground truth, you can track the model performance as well. So when it comes to changing distribution, like what kind of changes are expected? So there are two ways in which, or just two names given to two different types of changes. One is you trained on a certain data, like let's say we used applicant income, and as you can see, the mean of applicant income is well below 40K. And when the model was put in production, and we received a bunch of requests, and we plotted that the real-time distribution looks very different, and the mean is well above 40K. Now, will this affect performance of our model? We don't know, but certainly distribution has changed, and there is a sudden change. This is called as data skew. The skew can happen with the schema as well, as in like, for example, in categorical columns, you're probably expecting a category as a value, but you get some random string as value, or categories, the superset has changed. So there's a skew there. There is another way of distribution change called as data drift, where your initial distribution, if you see, it does start looking similar to your training data set, but eventually over the period of time, it sorts of drifts away, and it may or may not impact performance of your model. So this is a report generated by a library called Evidently. There are very nice libraries in Python called Evidently and Alibi Detect, and many more actually. So they generate this report. They use a bunch of statistical analysis tests on the data. On the left hand side you see reference data. On the right hand side that's the current distribution that you see in production. And it shows you the plots. It shows the p-value of your the hypothesis testing if that is done on that. And it shows whether the drift is detected or not. So it's like as simple as that for us. We can use this as part of our CI/CD pipeline. Okay, so now we had, as a DevOps engineer, we did put our model in production. We did put a data drift monitor on it, and we gave it baseline data statistics, probably data statistics of our training data. Then we did put model performance monitor, and we gave it baseline performance metrics of our training data. The serving set was given to drift, data drift monitor. It detected drift. But we said, yeah, it may not affect performance of my model, and so I don't want to go for retraining. But now, when I got access to ground truth, we gave it to model performance monitor, which also detected drift, and now we must retrain. There is like no option. But now, which data should be used for retraining the model so as to get better performance? So that if we understand what kind of drift have we experienced in the production environment, then that helps us to decide what kind of data we want to use in to retrain our model, to create the second version. Now this is, the definition is based on the concept of probability. The first line is when you don't have access to ground truth, but what you have experienced is that the joint probability of your feature and label has changed. So there is like change. You don't know whether it's performing badly or what. Now you don't have new training data because you don't have ground truth. So how do you retrain? Assuming that model may performance may degrade, you can still retrain. You can have that data, you can manually label the data in some way or the other, not appropriate for this loan approval use case of course, but for some other use case probably. And then you can generate training data, a little bit of it at least, and try to see if that improves the performance. There is something called as covariate drift. When you have access to ground truth, what this says is that, okay, my equation has not changed, as in my applicant income still has good effect on loan being approved or not. But the distribution of applicant income itself has changed, and this may or may not affect performance, like overall the performance metrics. But in this case, it becomes a little bit easy because you have access to ground truth, you have new set of data, you can simply use it to retrain your model and see if it works better. And the third one is a little bit tricky to track, as in like it's a concept drift which says that, okay, my equation of x and y itself has changed. And to understand, we typically give this COVID example because it becomes easy to understand. So for loan approval, let's say after going through this pandemic for a year and a half or 2 years, now government asks a bank to be a little bit lenient. This is all hypothetical situation, okay? Little bit lenient with approval of loans. And now banks start considering other features like health, some health details of the patient, whether that person, applicant contracted COVID, the vaccination status, and so on and so forth. So there are some additional features being considered now. And the effect of applicant income on the predictive ability of applicant income has now changed. So this is a concept drift. Here you have to go back to study phase. You need to understand what features make sense now, get that data, and then train the model. So this is a little bit tricky. Okay, so now in our case, let's say we have to come back to our use case, and we are saying that we just experienced this applicant income drift, and which was not very severe. There was no concept drift at all. So we got access to latest training data. We retrained the model, and the data scientist has released second version of that model, registered in my model registry as well. But now first version is already serving in production, and we want to upgrade that version now. So how do you do that? Now these two cases basically tell you how to evaluate your model. This is not for actual upgradation, but you can put your model in shadow deployment kind of mode, where all the requests are given to both the models, and okay, I should not stand here probably. And you can evaluate this new model silently, and once you're happy with the performance, you can think about upgrading it. The other is A/B testing. This is typically helpful when you have a concept drift and you want to evaluate if after adding health detail and after adding these 3-4 new features, whether my model performs better on the real data. Because you see performance metrics are good on your training data, but in real life also you need to evaluate separately. Here you can put the two models in A/B testing kind of mode, where 50-50, let's say, or based on your own distribution, the requests are divided between two models, the performance metrics are evaluated, and then the best model is picked based on that. Now this is for actual upgradation of the model. For our use case, we say that we cannot stand downtime at all. So what do we do now? Then we create a staging environment, which is similar to your production environment, and the model gets prepared, the model gets evaluated silently, probably in some way. And when you're happy with that performance of this new model, all the requests, the calling code starts pointing to your new model. So the old model is deprecated or probably kept in as a backup environment if something goes bad here. So this is blue-green deployment. Now let's say you don't want to have all the models, all the requests suddenly given to the new model, but you want to evaluate as well as upgrade at the same time. You don't want to have two separate phases. So what do you do now? You create a canary deployment where the new model is, the load on the new model is increased slowly based on how it performs. So you start with 10%, 20%, so on and so forth, and you reach to 100%, where the total upgrade has happened by now. Okay, so now with this we saw how the journey of our model. Yes, sure. So I will just cover one slide now, and there is one more slide which probably will you can look at the presentation later. So there is an angle of responsible AI, and I want to discuss how we can incorporate responsible AI as part of our MLOps framework. We already discussed one angle which is reproducibility, and that can be taken care by your experiment tracking. There is another angle which is accountability. You want your model to be accountable. You want to trust the predictions made by the model. So and model is going to give out predictions based on what kind of data was used for training. So your data may have bias. Like in this case, there is a column, there is a feature called property area, and the middle one says that okay, a lot of rejections are there for people living in rural area. So your data set itself has a bias. Now model is going to learn that bias. It's not possible to get 100% bias-free data set. So what you can, but during training, the model may blow up that bias, and eventually the predictions made by the model could be biased. So you need to track these two metrics, bias fairness metrics, and the explainability so that your model is transparent, so that people can trust the prediction. Basically, you need to log all these details in your model registry along with your experiment tracking, so that based on these two things, your model risk manager can take a final call whether to approve that particular model or not. Okay, so after that I just had this one slide where we say that okay, organizations start with data, they want to experiment with data, so data scientists start experimenting, but everything is handled by them. And unless organization sees ROI, they don't want to invest a lot in creating whole MLOps culture. But at this stage, at least having experiment tracking and model registry helps. You can have ML flow, which is a very simple pip install library, and that gives a fantastic UI for these things. Now second level, you have better things, but you don't have separate teams. Now this second level is also important, because this is the level where you can actually start thinking about separate MLOps team. Organization has observed ROI, and there are few models in production. So it's good time to actually set up a separate MLOps team, think about responsible AI. It's not too late to think about responsible AI, and it's not too early also to think about feature store. So this is a good level to start, setting your MLOps practice. Third is basically, almost everything is there except for monitoring. Next, so you should have you should automate your monitoring process as far as possible. Next is like you have good monitoring, except the last level is where you have this MLOps as a culture of your organization. As in like everyone knows that, okay, these are the tool set, this is how we, like these are the processes that we need to follow when I need to develop my new model. So it, like I have written there, it becomes part of your business DNA. So that's what the, level 5, last level of MLOps is. And yeah, so that's all I had on the operationalizing AIML systems. So, yeah, thank you. Thank you so much.
Thank you. Thank you, Reshma. Thank you so much. A small token of appreciation as well. Yeah, so on your behalf, we have planted a sapling. And this is a certificate with a QR code. You can look at the plant. So we have a few minutes while we set this up. So please be patient with us. So guys, we are now set up and we are ready for our next session. Our next session is around emerging technologies in testing automation. Now, automation is the buzzword around for everybody, and we hear it a lot, but we are going to talk today about testing automation. So emerging technologies are central to the digital transformation that is underway, not just here in the region, in India, as well as globally. These emerging technologies are enhancing the quality of applications and reducing time spent on testing of software and increasing the efficiency in the process. On that note and on that topic, we have today two gentlemen here, Rajeshwar and Deepak, and they represent Tietoevry, and they are going to talk about how you can bring in emerging technologies into this process. So on that note, over to you, and take it up from here. Thank you.
Thank you.
Thank you. Thank you so much for the great introduction. Okay, so I would like to start our talk by asking all of us a question, why we all are here? Okay, and probably all of us would answer, we all are here to understand what is happening around in the industry. And why we want to understand that? We want to understand that because we want to stay relevant. So in next 20 minutes or so, let's try to stay relevant and see what are the emerging technologies in test automation space. Okay, so we are going to talk about hyperautomation. We are going to talk about hyperautomation in testing, how the tools and platforms are reacting to the hyperautomation space. We are also going to talk about some part about cloud testing, API first approach and how to test that, containerization uses in testing, and some other emerging trends. Okay? Okay, so this is a graph published by Gartner, which basically talks about how the testing is evolving. So according to this, we are already in the era of value streams, and this will be dominated by AI augmented testing. So what typically we expect is our applications are going to get complex, and the rate of change is going to be very high, right? And we expect with the new age technologies and other approaches that are coming up, the delivery cycles will typically go down. And we also expect that testing efficiency or efficacy will go up, and let's see whether it's true or not. Okay, hyperautomation in testing. We all might have heard hyperautomation in terms of processes, but let's see what it means in terms of automation testing. Okay, so we all know how an enterprise application look like, and now enterprises are adopting composable architectures, which basically means our applications can be assembled, reassembled, expanded in order to deliver innovation, right? Innovation and to cope up with the rapidly changing demand or accelerated business changing demands, okay? But what that essentially means for us as an automation tester, I have to test rapidly changing business scenarios which might span across multiple technologies, multiple platforms built by different vendors or companies. I have to deal with a lot of data which might be highly structured or highly unstructured, right? The degree of automation will be varying because with the introduction of these technologies like artificial intelligence, our applications are also going to get smarter, right? So we need a smarter way of testing these, right? So what approach we need to take? We need to take a business-driven, disciplined, platform-based approach to test automation also with orchestrated use of heterogeneous tools and technologies like RPA, AI, and ML. So understanding the challenges, let's see how our industry is reacting to this. Okay, and we all understand what are the different challenges in scaling automation. Release frequency, time and effort required to build our test cases on different platforms. Of course, the automation skill set is a challenge. And what it collectively means that the rate of automation is typically very low, and it's typically with high maintenance cost. So how the platforms are reacting, or how the industry is reacting. So first approach we are taking is low-code, no-code tools, which basically means very little programming knowledge would be required to develop the test cases, right? Initially, when these tools came up, they came up with a very basic set of capabilities with libraries like Selenium and other libraries for testing APIs. But with the evolution of technologies like artificial intelligence, now what they are doing is, or the platform is capable of, is using computer vision and machine learning. They are capable of identifying your screens and elements as a human eye will do, right? And with the help of complex neural networks, they can perform operation as well. And I'll talk about it more. And using natural language processing, we can write test cases or test scenarios in human readable language. Another feature that these tools or platforms are coming up with is pre-built behaviors and assets. So typically we use applications like from different companies, built by different companies and vendors. So in collaboration with these companies, they release pre-built behaviors or assets, so we can readily download these assets from the marketplace, and we can automate quickly, right? And what advantages does these tool or this approach provides us is, of course, we left shift the functional testing and API testing, accelerated test design, simple script creation, and resilient script, as the scripts are not based on the physical properties of element. They are identified using computer vision and machine learning. The scripts or automation scenarios can be self-healed using this, right? And of course, the reduced skill set. So we just talked about the functional aspects of it, but these technologies are changing how we are doing performance testing or performance engineering and security as well. If I talk about performance engineering, the observability tools that we have these days using AI can predict performance anomalies way ahead of the incident, when the incident actually happens, right? The models can generate synthetic canned data for us, which can be used for your performance engineering practices. If I talk about security, there also the right shift approach. If we talk about, there are applications like which is like running in production, which is real-time application protection applications, which can intelligently detect the attacks happening on the production system, and they can avoid it. Okay. And this is an example of low-code, no-code tool that we have built in-house in Tietoevry. And this, using this, basically, we are creating our test cases, functional test cases, and these same test cases are being used for performance and security testing as well. Okay, so those of us who love programming, and what we do typically is we go to Google and search for code, we find the relevant code and try to create our application, right? So there are intelligent, plugins that are coming up, which we can directly use in our IDEs, and which can intelligently create code for us. I'm trying, so here you are seeing on your screen, there is a demo. It's built with code, Git Copilot, but there are other tools like Tab9 and all, which can be utilized for the same purpose. So here it's using natural language processing, reading the comment that I have provided, and suggesting me the context relevant code. And if you see, now it will be creating an entire class for me looking at the comment. So a class will be created. See, so how awesome is that? right? So of course, there are other toolings which can, or other plugins which can liberate us or from generating unit tests, but I'll not talk about that. It's kind of based on similar thing. With that, I'll hand it over to Deepak.
Thank you, Rajeshwar. Okay, we had a wonderful panel discussion in the morning on API strategies. Let's see now what that means from the test automation perspective. API first is an emerging technology trend which treats API as its own product. What happens in product development? We first try to understand consumers' needs. Then we develop product design, and then we validate it from the consumer's perspective. Same thing happens with API first. We first try to understand consumers' need. Then we develop API definition, not the actual API, just the API definition. And then we test it if it meets consumer expectations or not. Now, what this means from testing perspective? This is a significant shift left in testing approach. With API first, the contract integration testing needs to start even before development team starts with the coding. That's a significant change and shift left in approach. So there are two challenges here which testing needs to address. Let's see which are those and how those are addressed. So first, I write my API definition using API definition tool, which automatically generates API definition JSON. After this, I write my consumer integration test specs and my mock API service. And when I run these test specs against the mock API service using the tools like PACT, it automatically generates interaction contract JSON, which has all the interactions between these two. After this, what I do is, using mock validator CLI, I validate this contract JSON against my API definition JSON. And if this fails, that means either my API definition has some flaws, or there is some flaw with the way that my consumer integration test specs are written. In any case, I rectify that and make sure they both are in sync with each other. It is only after this that I write my actual API service and my mock consumer, which directly utilizes this interaction contract JSON, which was used in consumer contract testing. And now, when I replay all these interactions against my actual service, and then if this passes, that means I'm assured that my API is in sync with what my consumer is expecting, and so is my API definition. It is only after this that I write the actual consumer and do the full-fledged integration test. Moving on to the next topic, which is cloud testing. When we say cloud testing, we are here referring to testing cloud native resources. Now, there are three ways in which I can test my cloud native resources. The first one is resource group verification, where I can test how my resources are created and configured. I can do this immediately after my resources are created, or I can do it even before the resources are created using the infrastructure as a code template checker. So this was the first one. Second one, using Cloud Monitor, I can test how my resources are working after being created. And the third one is using cloud policy. I can check the compliance of my resources against standards. Now, these standards could be international standards, national standards, or custom standards laid down by my company. Now, let me give some examples. If I take an example of SQL Server, resource group verification will tell me if auditing has been enabled on my SQL Server or not, backup has been enabled or not, transparent data encryption has been enabled or not. Cloud Monitor will tell me how is my database transaction units consumption, or is there any excessive wait time for execution of my queries. Then if I take another example, let's say in case of app service, resource group verification will tell me whether HTTPS has been enabled or not, or monitoring will tell me if there are any failed requests or not. And if I take one more last example of virtual machine, in case of virtual machine, verification will tell me, let's say for example, if a remote connection has been restricted from the internet or not, or monitoring will tell me how is my CPU resource consumption, how is my memory consumption. And then moving to the last part, which is cloud policy. So here it will tell me how is the compliance of my resources against international standards like ISO 27001 or CIS, or national standards like US HIPAA or Australian government, Canadian federal, UK official, or any of the custom standards defined by my organization. Here, the best part is that all of this, which I just mentioned, can be completely automated and integrated into my DevOps pipeline as quality gates, so that I can assure that all these tests which are defined by me automatically pass before I release anything to the production. If I give an example of Azure, for IAC template checker and resource group verification, we have Azure Security Kit. For monitor, we have Azure Monitor, and for policy, we have Azure Policy. So this is how we can do the cloud testing of our cloud native resources. Thank you. Over to you, Rajesh.
Thank you. So, moving next. So, containerization or the use of virtualization technologies in testing. Okay, so this is kind of interesting, and previously in development we all are aware where and how the containerization technologies can be used, right? But let's see how this can be used or is being used in testing. So there are multiple use cases, but I here try to collect few so that we can build some context. First, basically we all understand what containers are. Containers are lightweight, scalable, isolated environments. So let's see how we can use. So the first use is you can use them in building your automation frameworks. So towards the right, you are seeing an automation framework that we have built in-house. So basically it's an security framework which we are using in our CI pipeline. We are performing dynamic application security scan. So it's built on top of Ubuntu, and it uses ZAP and JMeter, and entire networking stuff is handled there. So typically when you try to execute test cases, we need proxies and all. So everything is configured there. So what advantages it had bring to us is like this is portable. Our multiple teams are using it, right? These are lightweight. We don't need a heavy infrastructure to be set up for security testing. Highly reliable, right? So depending upon the context and the usability of these containerization technologies, we can also come up with the frameworks like this. Okay. So another part, we are mostly dealing with when in automation testing, we are dealing with a lot of tools like reporting tools and all. So what trend I am seeing is more or more these kind of tools like dependency track or defect dojo, they are all coming with this containerized deployment. So that is where we are also finding that more and more use of containerization or cloud-based technologies are being used. Execution dependencies. We all know how the era where we were struggling with setting up execution dependencies for running our functional tests, like set up take a machine, set up Selenium grid, maintain those grid. All those kind of hassles can be taken care by these lightweight containers. So here we can see on a screen we are using test containers, and you can spin the container from your test code. It will spin up a container for us, execute the test, and it will report back to us and destroy the containers. So it basically removed the dependencies from setting up my execution labs, right? Also, another way these containers are being used is to test dependency, integration testing. So you can put your dependency in the container and you can run your integration test very easily. So it created a container, it destroyed it, and then reported back. Yeah? Some of the other trends that we are seeing, like adaptation to chaos engineering and left shift in non-functional testing. Some of us might feel that these are becoming mainstream, but if we are not already doing it, please try to adopt these practices. Chaos engineering, try to break your system in if not possible in production, try to break them in pre-production system by introducing faults, run a lot of experiments, and try to test the resiliency of your applications. Left shift non-functional testing, and we had a session on DevOps and security previously as well. But if I talk about security, try to bring in security in every phase. Do threat modeling, perform SCA, SAS, DAST, penetration testing, and as I said, you can also implement runtime application protection in productions. Right? Talking about performance testing, you can start with the single user test, bring in your performance early, monitor the trend lines, bring observability across every phase in CI cycle, right? And also you can, using these smart tools that I talked about, you can also monitor performance of your application and get the anomalies, performance anomalies very early in the phase. I think, we can take some questions if you have. We still have time, right?
Yes, any questions?
Yeah.
Yeah.
Yeah, okay. Thank you, guys.
Thanks, everybody.
Thank you so much. Please stay. We'll have to. Thank you so much. We want you on the dais, please. So, as we have been informing, we are planting saplings on behalf of each one of you. So we'd like to give you a certificate for that and also a small token of our gratitude. Thank you. Thank you so much. Thank you. Your laptop. Rajeshwar?